Okay, I think we are ready to start. Welcome everyone back to day 3 of summer school. We are really excited to have you here today. I'm just, if my mouse cooperates, briefly giving you the introduction for today. So I'm Imme McGovern, and we've had this up the other days, but because we have new people every day, I want to point it out because we are really committed to ensuring that we are providing a safe, productive, and welcoming environment for all participants. The full code of conduct is available off the summer school website, but we have moderators that are moderating the Slido, and we'll be making sure that we continue to be safe, productive, and welcoming. It has been a fabulous set of discussion for the last 2 days, and we are really looking forward to lots more today. What we are doing today is we are focusing on ethical and responsible AI, specifically focused on ethical and responsible AI for weather and climate, but we are talking a lot about ethical and responsible AI in general. Our opening talk, we're about to introduce our speakers. So we have our opening talk with our keynote, and then we have a short break, and then we're going to talk about how we turn this need for ethics and in AI for weather and climate. And then we have a talk about AI and ethics at IBM. And then we're going to do something different for the last session. This is modeled a little bit after what happened at AMS 2 years ago. I think that was the last time we were all in person, where there was a fabulous fireside chat where the speakers got together with the moderators and they had a good discussion, and they took questions from Slido actually at AMS as well. And we're doing the exact same thing here today. We have Slido for us all day. So you can go to slide.do and put in TAI4ES. You can just scroll down if you're watching just the live stream and you want to scroll down and get there that way. Or you can scan this QR code if you want to do it mobile. You vote on the questions and they pop up to the top, and then we have moderators that are selecting the questions. One thing I do want to say, since we're using Slido to do questions all day, and this was definitely something that happened yesterday that got confusing, make sure you put the name of the speaker in your question. So if you really want to ask a question of Catherine or Lauren, our first 2 speakers, then say at Catherine or at Lauren, and then we know who the speakers are being addressed to. I think that's it for my introduction, and I'm going to launch into the introduction of our speakers, but I'm going to stop sharing screen for a second. Okay. I have entirely too many windows up, and I need to make sure I have the bio. We have 2 fabulous speakers that are opening keynote talk, and I'm going to introduce one, and Ann Bostrom, who's our co-chair, is going to introduce the other. So Lauren Klein is an associate professor in the departments of English and Quantitative Theory and Methods at Emory University. She directs the Digital Humanities Lab. Before moving to Emory, she taught in the School of Literature, Media, and Communication at Georgia Tech. Dr. Klein works in the intersection of digital humanities, data science, and early American literature with a research focus on the issues of gender and race. She's the author of An Archive of Taste, Race, and Eating in the Early United States, and with Catherine D'Ignacio, Data Feminism, which is what we invited them to talk about. With Matthew Gold, she edits Debates in the Digital Humanities, a hybrid print digital publication stream that explores debates in the field as they emerge. And her work has appeared in leading humanities journals, including PMLA, American Literature, American Quarterly, at technical conferences, and she's been supported by grants from the NEH and the Mellon Foundation, and we welcome her. And now Anne is going to read Catherine's bio.
And good morning. I'm Ann Bostrom from the University of Washington, and I'm delighted to introduce our other speaker for this first session, Catherine D'Ignacio, who's an assistant professor of urban science and planning in the Department of Urban Studies and Planning at MIT. She is also director of the Data and Feminism Lab, which uses data and computational methods to work towards gender and racial equity, particularly in relation to space and place. Her work focuses on feminist technology, data literacy, and civic engagement. With Rahul Bhargava, she built the platform databasic.io, a suite of tools and activities to introduce newcomers to data science. Her 2020 book from the MIT Press, Data Feminism, co-authored with Lauren, charts a course for more ethical, empowering data science practices. Her research at the intersection of technology, design, and social justice has been published in the Journal of Peer Production, the Journal of Community Informatics, and the Proceedings of Human Factors in Computing Systems. Her art and design projects have won awards from the TAN Foundation, Turbulence.org, and the Knight Foundation, and been exhibited at the Venice Biennial and the ICA Boston. Welcome, Catherine and Lauren.
Thank you so much, Amy and Ann, and to everybody who's viewing. We were really honored to be invited to speak to the summer school, and we're really grateful for people's time during, these Zoom hours. They're pretty precious hours, and we're grateful for people's time during the summer and for spending some of those sort of precious online hours with us today. So without further ado, I'm going to start sharing. Hopefully that looks okay. Please tell me if it doesn't. So yeah, the roadmap for today is Lauren and I are going to tell you a little bit about our motivations for writing Data Feminism. We want to ground folks in what specifically is the definition and the sort of definition and the grounding of which type of feminism do we mean that we're drawing on in the book. And then we want to show you a couple of examples that emerged out of the book. So that's sort of the plan for today. And we've already had these lovely introductions, so we won't further introduce ourselves. Maybe the only last important thing to say here is that the book is open access, which we're really happy about. And so if you go to our book's website, it's at the bottom of the slide, datafeminism.io. You'll see a big button that says read the book. That'll take you right to the open access version. And so you can check it out there. So I think that's all we have to say on this first slide, and I'll kick it over to Lauren to start things off.
Thanks so much, Catherine, and thanks to everyone for listening in. So I think I'll start by just saying that we see data feminism as one small part of a much larger and actually exciting and growing body of work that is collectively trying to hold corporate and government actors accountable for their sexist, racist, classist data products. So you could think of things like face detection systems that can't see people of color. We've seen this a lot with all these remote proctoring systems that have been put into place during the pandemic. You could think of hiring algorithms that demote applicants that went to all women's schools. This came to light after a lawsuit was leveled against Amazon for an internal system that did just this. Child abuse detection algorithms that unduly punish poor parents, and more. And at the bottom of the screen, you can actually see some of the projects that have done work on these particular issues that I just named, and that really inspired us to write the book. Because the bottom line is that these examples, they just keep on coming. Every day, every week, there's, a new headline in the news about one of these new discriminatory systems. And that provided us with our motivation. We find ourselves in this situation where corporations tend to see data as the new oil. This is a phrase that has been in play for at least a decade. And when corporations use it, they mean this in a good way, right? Data seems to them to be this untapped natural resource. If you can figure out how to process it and refine it, it can lead to tremendous profit for them. But women, and particularly women of color, as well as Indigenous people, immigrant communities, LGBTQ folks, and more, experience this very same process of data extraction, since if you're talking about oil, that's really the operative metaphor here. It's just another instance of the same old oppression. And like I began by saying, we are by no means the first ones to have made the case that this oppression is real, that it's ongoing, and that it's really necessary to dismantle. But what we try to do in the book is explain how feminism, and intersectional feminism in particular, and more on that in just a minute, has actually been focused on precisely this thing for a very long time, on dismantling instances of oppression and the forces of power that cause them. This essentially is the work of feminism. And so what we try to do in the book is translate some of those teachings to a data science context.
Oh, do you want me to take this one, Lauren?
I think so, yeah.
Great. So we like in these talks, we do talks to a variety of audiences, and the book really has aspired to try to reach audiences that don't necessarily come together very often. So like women, sexuality, gender studies, race and ethnic studies, data science, scientists, urban planners, journalists, folks in media. And so like we aspire to reach a broad audience. So that's why we like to ground some of the terms that we're using and not necessarily assume that people have familiarity with different types of feminism, with the history of feminism, and so on. And so we start with sort of saying sort of where we're coming from to do a little bit of this level setting around feminism. So what you see here is an image from the 2014 MTV Music Awards. And this is when Beyonce, who's the performer in front, she projected the word feminist behind her. And she actually sings the definition of feminism in her song Flawless. And she's actually sort of singing this dictionary definition, which is here. So who is a feminist? A feminist is the person who believes in equal rights for men and women. And we added non-binary people because we feel like Beyonce would agree with that. But so what we get from this definition is that feminism is a belief in equality. But there's another definition of feminism. And so if you believe in gender equality, then all you need to do is look around and see that the world has not yet realized equality for all genders. That's just plain, whether you look at data or whether you look at anecdotes or something else. It's very clear that world has not yet been realized. So feminism implies a commitment. And so it is a political commitment to organize activity on behalf of women's and non-binary people's rights and interests. So we have that feminism is a belief in equality. It is political action to realize that equality. And then feminism has a third definition. And then this one is, I find pretty exciting, actually, which is that feminism is a set of theories and ideas. What this means is that it's an intellectual heritage. It is a body of knowledge. It is robust. It is decades, if not hundreds of years old. And these are theories that we can draw on as we face current ethical problems of inequality and how to navigate these things in our work. These are theories and ideas that can inform this work because we have spent so long thinking about it. And these theories begin by thinking about issues of inequality with respect to sex and gender. So in a lot of cases, that really is the starting point of a lot of feminist thought. But the past 40 years of scholarship and also our current political reality have brought many more dimensions of inequality into the conversation, including race, class, sexuality, ability, and many more things.
So this brings us back up to this idea of intersectional feminism. And in our view, and this is what we say in the book, feminism in the year 2021, so right now, must be understood as intersectional. And again, some of you may be familiar with this term already. Intersectionality is a term coined by the legal scholar Kimberly Crenshaw, which she uses to explain how social inequality cannot be described in terms of only one dimension of difference, like gender. So if we're talking about inequality or oppression, we must be talking about the intersection of the many factors and forces that produce it. And again, this includes racism, classism, colonialism, and so on. But the key thing to understand about intersectionality, and this is actually something that's often overlooked in casual invocations of the term, and I think it's really important. So intersectionality isn't just describing markers of individual identity. So it doesn't just mean, like I, Lauren Klein, I am a white cisgender woman. I live in the global north in the US South, except not right now because I'm in New Jersey. It doesn't just describe these markers of identity. What intersectionality is describing are the structural forces of power and their intersection that make those aspects of my identity matter, that produce the instances of privilege that I experience most of the time, and on occasion, the instances of oppression that I face. And it really has been the work of women of color feminists and Black feminists in particular that have foregrounded this conversation about forces of power. And so in short, intersectional feminism, which really gives us the underlying framework for our book, it's not only about issues of gender. It's not even only about women, it's about power. It's about who has power and who doesn't. And in today's world, data is power. So you see this in the idea of data as the new oil, right? A thing, a fuel that drives things. You also see this in the idea of data as the same old oppression. And so intersectional feminism, when applied to data science, can help that power be challenged and changed. So our argument in a nutshell is that data science really needs feminism, actually quite badly, if we ever hope to overturn these power imbalances that we face in the field.
So as we wrote the book, we sort of asked ourselves what we've learned from all of our schooling and feminist scholarship. We looked across a number of different fields that have tried to operationalize feminist work. And so there's really interesting ways in which the field of law, like legal theory and policy, has worked to operationalize feminism. Economics, human-computer interaction, geography and critical cartography and map making. So we're really particularly interested in sort of how have people translated a kind of feminist orientation, a kind of feminist ethical practice to doing the work in a particular discipline, like designing laws and policies to designing maps. Because we felt this was ultimately what was useful if we were going to formulate an answer to the broad question, what does a feminist data science practice look like? That's sort of what we're trying to draw from. It's really like principles for practice in a lot of ways. And so from that scan, we came up with these 7 principles. And these for us encapsulate the most important aspects of feminist theory as it relates to data science and also to data communication. And the goal here was, like I said, to operationalize feminism, to really think about how do we use feminism to guide the work of people who are working with data or who want to work with data, or even for people who want to refuse to work with data. So we don't have time to go through, like each one of these today. But one thing that I think is important to point out about these principles is, first of all, this is the way that the book is structured. So there's 7 principles. There are 7 chapters in the book. They go through the principle in like this in order. We, in each chapter, try to introduce some of the feminist theory that informed the development of that principle. So some of the most important thinkers in relationship to that principle. And then at the same time, what we try to do is introduce the reader to, sort of real world people, either currently, or we do have some historical examples as well, who are actually doing that principle to sort of illustrate that principle in action and also show that it is possible, like it's already happening that people are using data science to examine and challenge power. It's already happening that people are embracing pluralism and using participatory methods in data science. Like all of this stuff is already going on in the world. And so we can learn from it and draw from it. So that's sort of the structure of the book. From here on out, we are going to just take you on a little bit of a tour of a couple of the principles and tell you about some of the examples that we try to surface. And maybe just the last thing I'll note on this slide, you may note that there are 2 principles that have to do with power, examine power and challenge power. They're right at the top, at the front of the book. This is because kind of just building off that definition of feminism and intersectional feminism as really centering the role of these forces of power. This is what is at the heart of the feminist project. It is this commitment to really centering inequality and forces of inequality and then challenging those. That sort of feminist approach to data science says this should be sort of what is at the core of our kind of mobilization of data-driven and computational methods. We should be using these to challenge inequality and seek justice. I'll pass to Lauren for our first example.
Excuse me. So to this point, one of the projects that we talk about really early on in the book, in the chapter about examining power, is this one that you're looking at here. Excuse me. So this project is called The Library of Missing Datasets. It's by the artist and educator Mimi Onuoha. And missing data sets is this phrase that Onuoha employs to describe data sets that a reasonable person might expect to exist because they address issues of pressing social need. But because of various reasons, usually various political reasons or reasons related to power, they don't actually exist in real life. So data sets like trans people killed or injured in instances of hate crime, there's no national comprehensive database on this. People excluded from public housing because of criminal records. Again, this is a real problem due to the way in which certain laws are written, but we are not counting the number of people affected by this. Or for a more topical example, any number of data sets relating to COVID. CDC no longer counting asymptomatic transmission that doesn't end people in the hospital, right? This is another missing data set. I want to just back up and say what you're actually looking at here rather, is how this art project is exhibited. So it's actually exhibited in two ways. The first is a GitHub repository. That's what you see in the screenshot on the right. You can Google it and find it and read it right now. It actually has a really beautiful artist statement that accompanies the description of the project. But then the second is a physical installation. That's the file cabinet that you're looking at on the left. So the files are labeled with each of the titles of the missing data sets. The idea is you go into the gallery, you encounter the file cabinet, you tab through the file folders, you find one that seems interesting to you or something you didn't know about, you go to open the folder, but then it's empty. And the more profound point that Onuoha is trying to make here is that they're empty for a reason, right? A specific reason, and this is the profound imbalance of power with respect to data collection in the world today. So this imbalance of power is what determines what data are collected and what data are not, or in turn, what research is conducted and what research is not, right? So who has this power? Governments, moneyed institutions, moneyed academic institutions, right? Who tends not to have the power to collect large amounts of data? Minoritized groups. And so this is why a feminist approach to data science more broadly must begin with an analysis of power, because far too often the data sets that we can access, and then in turn the questions that they prompt, have already been affected or overdetermined by the larger imbalances of power in the world today.
So I was talking about this principle of examining power. And then when we talk about challenging power in the second chapter, we talk about a variety of ways that we can use data science and computation to challenge power. And one of the examples that we give is the work of Maria Salguero, who works in Mexico on the topic of feminicide. For those of you who do not know, feminicides are gender-related killings of women and girls. It includes cis and trans women. Increasingly, and in fact, in all Latin American countries now, feminicide is now legally codified. Like there's actually a law criminalizing feminicide. And this is really thanks to a very strong feminist movement in Latin America, which has gotten this on the public agenda. However, even though the state has defined feminicide as a crime, they do not systematically collect data on feminicide, certainly not in the Mexican context, and basically not in any other countries. And so this failure to collect, and basically kind of failure to implement the state's own laws and provisions, is the subject of emerging public anger in Latin America as well. So for folks who want to learn more about the topic, you can look at the hashtag Ni Una Menos, which means not one less woman, basically. And so frustrated by this lack of action and implementation, Maria Salguero, she doesn't even like the term activist, she's just like a Mexican person. She decided to head straight towards the problem and to collect the missing data herself. And the really impressive thing about this work is that she has been doing it for over 5 years at this point. And so in that time, she has single-handedly compiled the largest archive of feminicides in the Mexican context. This takes 2 to 4 hours a day, logging these feminicides on a Google map She discovers about the feminicide killings based on reading media reports. So this is 2 to 4 hours a day she spends reading about violent deaths, and then logs on her map. She, using the map and the database, she has helped families locate loved ones who have gone missing. She has provided her data to journalists and to NGOs. And she's testified in front of Mexico's Congress multiple times about the data. And so in the book, we talk about this as a form of what we call feminist counter data. So this is a kind of an activist data collection that steps in when the state and sort of other counting institutions have systematically failed to ensure the basic safety of their population. So when institutions fail to count the right things, increasingly civil society actors are counting. And so this idea of counter data represents one way to use data to challenge power. And I guess there's one maybe just important caveat that I'll say there, since we're not going in depth about all the different ways to challenge power, which is that we just have to keep in mind that collecting more data is not always the answer to every social problem or to every social inequality. So you just need to think about, when is it appropriate to collect counter data versus when might it be actually exposing to vulnerable populations and exploitative to actually make them visible to institutions and to institutions who may in fact want to target them, harm them, deport them, and so on and so forth. So there's, it's not always clear cut, like just collect more data is always the right answer necessarily.
So this next example is actually also, or it begins with a counter data collection effort. But I want to talk about it in a little bit of a different context, which is under the rubric of embracing pluralism, which is another principle of our book. So what you're looking at is a map created by the San Francisco-based anti-eviction mapping project. And they also go as the AEMP. Since 2013, the AEMP has worked in collaboration with tenants' rights organizations and community groups in order to collect and map data about the eviction crisis in the Bay Area. And so what you're looking at is on this map, each red dot indicates a place where a person or a family was evicted. And the blue dots indicate places where the AEMP has also interviewed one of the people who was evicted from that place. And clicking on the dot brings up one of these interviews, like the one that you see screenshotted on the right. That's of a resident of Midtown named Phyllis Bowie, who's facing eviction from her home. And in the book, we draw a sharp contrast between the AEMP map that you were just looking at with the work of the Eviction Lab, which is based at Princeton. And in terms of the goals, right? The goal of the Eviction Lab is actually related to the AEMP. It's to present a national picture of the eviction crisis. And it's a worthy goal. This is a really valuable project. I actually teach some of their work in my own classes. But it's really wildly different in terms of process. So, and I think this is actually really instructive for people who work with data more generally. You might take a look at this map and think, okay, I'm pretty sure that I'm looking at bigger data, right? Looking at a map of the whole United States, their scale is larger. There seems to be more data points individually. I think it looks a little bit more rigorous, right? They're using like Mapbox or some sort of more professional mapping software platforms versus the Google Maps style map that we were looking at before. I think what I'm looking at here, this might be your assumption, is a more comprehensive picture of the problem of eviction in the United States. But the really interesting thing that the AEMP has shown is that the national real estate databases that the Eviction Lab uses actually significantly undercount evictions. And you can think for just a minute about why this might be true. So first of all, the real estate industry, not incentivized to count any more evictions than they have to, right? Very bad for business. Second of all, you can also think about all of the ways in which you can be evicted that don't involve being formally served with an eviction notice, like the papers that you get after you go down to City Hall, or your landlord goes to City Hall and files the paperwork. Your landlord cannot fix the leak in your ceiling. The landlord can fail to repair your plumbing. They can lurk in your lobby. There's all of these different ways that people or landlords can get tenants out of their homes without formally evicting them. And because the AEMP works with local community groups, so the places where individuals and families go and say, like, help me, this is happening to me, what do I do? And they've developed a pretty rigorous and comprehensive data collection process. They've actually gathered admittedly messier, but actually much more accurate and more contextualized data that in fact documents a greater extent of the problem at hand in the Bay Area. And in the book, we talk about this in terms of what is gained by embracing pluralism. And I'm going to turn to Catherine for a little bit more on this theme.
So, embracing pluralism in data science, as we outline it, is really means the incorporation of participatory methods. So really thinking about taking in a way more of a design-based approach to data science. And this is something that, there's a long trajectory and field of participatory design that has thought about how do designers collaborate with sort of end users and human-computer interaction and industry and other kind of spaces. There's also fields, like I'm in the urban planning department, and we have sort of long-standing participatory methods for engaging citizens in urban planning processes. So this idea of embracing pluralism is about thinking about how do we bring more people in to a process as a way of making it more equitable, also as a way of mitigating the inequalities that get baked into these systems that may or may not be known to the developers of these systems. But when we're embracing pluralism in this process, and we're saying, yes, let's do participatory data science, and especially if we're building, say, a system or a product that is then going to be used by many people that may scale to reach hundreds or even thousands of people or more, you can't bring all of those people to the table in a participatory process. It's just not practical, right? And so whose voices do we prioritize? And this is where feminist design, feminist theory has a really clear answer to this question. So following the work of Sandra Harding, Patricia Hill Collins, Xiaowen Baitou, a feminist design perspective takes power into account and really centers the experiences of the people at the edges and the margins first and foremost. So really thinking about, like, who are the groups that may have the most stake in this, and also the most risk of being negatively harmed by this. And those are the folks that we bring in. Those are the folks that we build relationships with and that we engage in participatory process. And so this is similar to what there's a fantastic book called Design Justice. And this is similar to the principles of design justice, where they say we center the voices of those who are directly impacted by the outcomes of the design process. And so the same is true for the design of data science projects, computational systems, algorithms that touch social, political, sort of human life. These are the folks that we should be working hard to build relationships with. And just to give you an example of this, sometimes there's questions about, like, well, if we're working in a participatory way, can we still build things that scale, right? Or does it mean we're always relegated to working hyper locally with, like, 10 people or something like that? And the answer to that is no. We try to sort of demolish some of these binaries between sort of qualitative versus quantitative and which is better and stuff like that. This is like really well-trod territory. And in fact, we can embrace scale, but also embrace participation and embrace the participation specifically of minoritized groups. And so this is a great example of this. This is the Global Atlas of Environmental Justice, and you can find this at ejatlas.org. And so this is both a kind of public-facing website, but it's also a research repository. They work in partnership with activists, civil society organizations, and social movements to systematically try to document ecological conflicts around the globe. And so like the folks who are kind of running this initiative actually built on longstanding relationships they have with regional sort of activists and civil society partners who are working really hard to try to document when these environmental conflicts arise, usually over resources of some kind, or usually because a community is being exploited and for some kind of extractive reason. And so by sort of unifying, sort of in coalition, all of these groups that are working, they can present this atlas at a global scale and enable comparative, global, and quantitative research questions, while also valuing the sort of highly localized, really specialist expert knowledge that groups who are on the ground documenting these conflicts actually have. So without sacrificing that commitment to pluralism, they can facilitate this global scale research. I think this is a really sort of fantastic model for what we might do in relation to participation, which is non-extractive. So here we're shifting to a new principle, which is around rethinking binaries and hierarchies. And so the previous examples have focused on the issue of power and people. So like who has power, who doesn't have power. But then we learn from feminist theory to really think more conceptually about structures of power and to specifically think about binary structures of power. There's a long history of feminist work, which have specifically taken the gender binary as its inspiration for thinking about binaries, and kind of presented long critiques of the gender binary. And what feminist theory helps us understand is how we need to be suspicious of binaries when we encounter them in the world. So if we take the gender binary as our, a good starting example of this, we inherit this idea that there are two genders, there's men and there's women. But what feminist theory teaches us is, well, first of all, this is a false binary, right? Because there actually are not two genders. So empirically speaking, across all time in history, there have never been two genders. So it's just false, it's wrong. So the fact that we have that binary in the first place is the wrong, like if it were a programming variable, it's like not a Boolean, So there's, first of all, there's a false binary. But then second of all, there's a second problem with the gender binary, which is that in fact, what it's hiding is a hierarchy. So instead of just having men and women and they're on the same playing field, actually we have men and women, right? And so there's a way in which one is on top and one is on the bottom. So first of all, there's a false binary. Second of all, there's an unequal hierarchy that is being hidden by those categories of classification. And so that's what feminist theory helps us start to think about, is like, how do we rethink binaries whenever we encounter them in our work and detect the false hierarchies that are being established by the categories that we're working with. And so that's what this next example takes up, is sort of thinking through these artificial distinctions, like things like nature and culture, subject and object, reason and emotion. And that's the subject, the false binary that we talk about in this next example.
So in the sort of Anglo-Western context in which we are mostly situated, we've been taught that reason is somehow better than emotion. And we see this play out in data science all the time, and in data visualization in particular, where it's very, very clear. So best practices for data viz often involve like a clean design, a minimalist aesthetic, presenting just the facts. But the question remains, why are these in particular our best practices, especially when research has shown that we interpret these aesthetic choices just as emotionally. So we tend to believe that these types of charts are actually more truthful than they actually are. So I'm thinking here of research by Jessica Holman. She's in CS at Northwestern. She's shown that just including a source line for a data visualization makes a person trust that particular visualization more. It doesn't matter whether the credit line actually describes a source that exists in the world or not. Or there's been really interesting work recently by Crystal Lee and a team at MIT that talks about how spreaders of misinformation or disinformation about COVID actually accompany their totally made up facts or made up data with very scientific seeming visualizations, because they know that these visualizations, bar charts, pie charts, and the like, lend an aura of objectivity to their, again, totally fabricated studies and data points. But we want to just think for a minute about the opposite. So visualizations that deliberately leverage emotion. And so that's what this final example helps us explore. What you're looking at in this slide is actually a set of screenshots from an animated visualization. It's by the design firm Periscopic, and the URL to look at the visualization is on the screen. If you want, you can watch it while I'm talking. I won't be insulted. It's the number of gun-related deaths in the United States in a particular calendar year. So this one in particular is 2018, but they've done this for a couple of years. And what happens in the visualization is that each of the people, each of the individuals killed by a gun in that year is represented as a single arc on the screen. So they're traced out one by one. They start out really slow so you can read the identifying information from each person. And then they get faster and faster until they create this sort of semicircular web that you see in the larger image. And it's overwhelming to watch. I find it really unbearable. And I find it unbearable even though, every time I watch it, even though I have at this point watched it probably dozens, if not hundreds of times. But that's actually the point, right? If you're watching it right now, it seems like it goes on for too long. But that's because there are too many people being killed by guns in the United States. They're actually using bad visualization best practices, and that the lines overlap with each other so that you can't perceive individual lines. They plot in effect too many data points. But again, that's because too many people are being killed by guns in the United States. What they're trying to convey is this is too much. This is an epidemic, and it must be stopped. And I should just back up and say that methodologically, it's no less statistically sound than any other study. I actually teach their methods section in some of the more stats-oriented courses that I teach. The data about the people derived from a national crime data set released by the federal government, crimes.gov, in case you ever were curious about that. One of the things that the project does is it actually predicts the expected lifespan of the person had they not been killed by a gun, and that lifespan is determined by a model released by the World Health Organization. But nevertheless, it was viewed with intense suspicion from the visualization community because it made us feel things. And a feminist approach here would say, that's not a problem at all that it made us feel things. And actually, it's a more compelling visualization because it blends reason with emotion. So it opens itself up to rebalancing this this sort of invisible hierarchy and rejecting this false binary. And what this results in is a much more capacious data communication toolbox that in turn allows us as designers, as analysts, to focus on what really matters in any sort of research process. So honoring the context of the data, listening to the lived experience that it documents, and then in turn, using our work to take action to challenge these imbalances of power that we encounter in the world.
So if it isn't already apparent, the principles of data feminism apply to every stage of a data science project. From inception and funding, which you might argue are like maybe the most important phases of a data science project, is sort of setting up the research problem or the question or the goal, and securing financial resources to fund that work. That might be the very, that might actually be the point where the most bias enters the pipeline, right? Where you set up the framing for all the work that follows. But then on through data collection, processing and cleaning, analysis, deployment, communication of results, use in the world. So, the goal here would be to both think about sort of how does inequality affect every stage of this pipeline, and how do we use kind of a feminist awareness, feminist analysis, feminist way of practicing to mitigate those inequalities and push back against them, and hopefully push them out of our informatic products and projects. So this brings us to the final point we want to make before the Q&A. And this point may be obvious from these examples, but it's worth stating directly as well. And it's that data feminism really insists on an expanded definition of data science and data visualization. So as you might have seen, many of the examples that we've talked about are not, they're not only algorithms, right? We've been showing you lots of examples of work by activists, journalists, librarians, communities, and so on. And so the data science that we model and outline in the book is not defined by the size of the data sets that people are working with. It's not defined by the credentials of the people who are undertaking the work. These concerns are continually used to exclude women and people of color from the field, as well as to exclude work whose contribution is really more socio-technical than just sort of a purely technical contribution. So if we expand our definition of data science, then we can see clearly that some of the most interesting work at that intersection of data science and justice, some of the most interesting work there is being undertaken by artists, journalists, humanists, librarians, community organizers, and activists. And some of that work does look like traditional data science. So we have a really fantastic research paper up there about human reporting bias in natural language processing models, for example, by Margaret Mitchell and her team at Google. And so that you can totally work in that way, a kind of classic traditional sort of data science published in academic journals way, and do very kind of justice-oriented work. But then at the same time, there's like interactive sculptures, which you see here in the middle. There's data journalism projects, which you see here on the right. And then there's even work by Data Therapy, where they create what they call data murals, where they work with community-based organizations to build their data literacy and capacity, and then produce large-scale murals in public space that come out of their data. So we have hundreds of examples like this in the book, and we selected these to illustrate our points and also to inspire our readers to action. Because on the one hand, we talk about in the book how data is at the root of many of our problems today, or at least reflects the fact that our world is a deeply unequal place, and that shows up in our corporate workplaces, and it shows up in our data sets, and it shows up in our algorithms, and it shows up in our data visualizations. But so, while it can be at the root of many of these problems, there are also ways to mobilize data science to be part of the solution to these problems. All right, and just last quick plug, we were invited to put the book into a couple of art and design exhibitions. We didn't really know how to exhibit a book, so we worked with a designer named Marcia Diaz, who created these fantastic data feminism principles infographics, and they're available for free. You can download them from our website there. And in fact, we've ended up, due to popular demand, producing them in a number of different languages. So we have 5 languages now. We're actually going to be adding, I think, 5 more languages later this summer. So, so stay tuned if that's of interest. And then here's many different ways to contact us, social media and emails and websites and so on. We'd love to hear from people who are using data feminism in their classes or trainings or in their families or friends, or if you found it applicable to your work in some way, we would love to hear about it. Or if you have critiques, of course, as well. So yeah, I think maybe we can open it for any questions or comments.
Thank you. Imme and DJ, are you going to select a top question, and Anne and I will take turns reading them?
I'm putting some in the chat for you, Amy.
Oh, okay. Yeah, if you click on them, that one's just a comment. So I had put into the chat about asking about questions, asking people to comment about questions that might be missing, but those are sort of more for later. There are some questions that are addressed just at Lauren and Catherine. So I'll read one if you haven't got one picked. There's one that says, Catherine, the issue of missing data due to a whole lot of reasons like security breaches, highly classified data issues, the availability of data due to expensive instruments to collect such data. So I guess they're asking about, those who are highlighting, that one's down at the bottom. There we go. So we're asking about, I had asked a question in the chat while you were talking about, think about missing data in the weather and climate, but this is asking about what about other kinds of reasons that the data might be missing. So I don't know if you can comment, either Catherine or Lauren, on that.
Sure. Yeah, I think it's great. And I think it's very apt because, I mean, I think for me, the comment here brings up these questions about who should have access to which data. I mean, in a lot of cases, when we're saying missing data, this concept that we draw from Imme-Onwuka's work, you know, this is really kind of presuming there's an implied set of expectations there that the data should be there, you know, that there's some kind of like public benefit to us knowing, for example, like how many mothers are dying in childbirth. Like that's something that we don't have comprehensive federal data on, just to give one example. And so, but I think what the commenter brought up is, you know, there are questions of like, you know, not all data should be public. And in fact, not all data about minoritized groups should be made public either. And these are these questions around sort of security, privacy, consent, I think, which is a really big feminist issue as well. And it goes back to that point that I made about counter data, where it's like, it's not always, you know, quote unquote, a good thing to be collecting counter data if what that data does is make vulnerable people visible in ways that could be harmful to them ultimately. So, you know, one of the kind of things we return to over and over again in the book is like really needing to consider all of these questions, all these ethical questions that arise with data are really questions of their relational questions. So like, who wants to know what about whom, who should have access to data about whom, the answer to the who in all of these cases really matters. But in the case of missing data, you know, I think there is a kind of idea of, I think that resonates with sort of what are, or maybe there's the question that it prompts is like, what are data that are genuinely missing that the public should have access to? There's a kind of right to know. We need transparency in order to be able to hold powerful institutions accountable. And that's a political question, right? That's a question we need to arrive at through a democratic deliberation, through political protest, and so on. But Lauren, I don't know if you want to pick up on that further.
No, that's a great response. I think maybe we should move on to the next question because I think that we'll come back to these same kinds of themes.
Well, that's a good idea. Then this next question relates to the previous question and has to do with a specifically with impacted populations. How do you put the most impacted populations at the center of policy discussion if, as you pointed out, finding these populations relies on potentially exploitative data collection?
Yeah, I mean, I think that's a really good question. And like I said, it really relates to what Catherine was saying about these who questions, like who is doing the data collection, in whose service or whose interest is the data being collected, and making sure, I mean, data collection doesn't have to be exploitative, right? So an easy answer to how to not to exploit impacted communities in data collection is like allow them to determine their own methods of data collection or the sites of data collection or the types of data. And I'm thinking in particular in relation to climate, there's this really great dissertation project that came out of my old department at Georgia Tech by someone named Jude Wenda. And he looked at how data on sea level rise is being collected in Savannah, Georgia, because Savannah is this really intricate ecological system and it's subject to incredible flooding, it's coastal and has like this internal archipelagic. Those of you listening probably know the more technical description for this, but it's very, very localized. And so there's all of this work that is funded by the federal government to sort of downscale large climate models to say what will happen on the coast in Savannah next month, next year, in a decade. And yet, even within Savannah, like that's not enough. There is specific locations that experience the effects of sea level rise on a daily, weekly, monthly basis. And so there was this really interesting citizen science project where they ran around placing sort of DIY water sensors in specific locations that have been decided upon by the community. And this was conducted through meetings with community members, and it led to people saying like, oh, this bridge always floods when I drive to work. And so they went and they put a sensor there. Or, oh, the playground in that school always floods, so the kids can't go outside. And the scientists, the climate scientists, worked in relationship with, I believe it was city government, because they had agreed upon a shared problem. They recognized again that it wasn't a binary solution. They could still do their modeling and their downscaling, and they could sort of take in the large scale models and the information that came from those models. And they could also listen to these very localized sort of DIY hodgepodge together sensors, and together, and again, this is the argument that comes back to pluralism. It's not just pluralism of people, but it's pluralism of approaches, right? Together, they result in a more nuanced, more detailed, and more accurate picture of the actual problem at hand. And I think that's a lesson, again, both about what can be gained scientifically from embracing this approach, and also how not to do this sort of top-down, outside-in process of doing science, and instead to sort of work with communities to listen to them and find out what the problems are and adjust the response and even the methods in response to what you learn.
Excellent. And I think, good, there's our next one. So on missing data, it's known that real climate data is Western focused, causing biased results. Acquiring climate measurements is an expensive endeavor that many states, and I would add many countries, honestly, cannot take on. Do you have any suggestions for scientists specifically to help with this problem?
Yeah, I mean, I think the most important part at this point, and we counsel this pretty much in all situations where you recognize that there is missing data or biased data, but you are sort of too small of an actor in order to do something on your own, is to just note that, right? In your studies, in your methods, when you're talking about like, what are the implications here, to note the absence, to note where more data collection is needed, more sophisticated measurements are needed, more active community or even national, national partners are needed, and to constantly be aware of just how far the results that you have obtained can take you, and then also where they stop, right? And where more research or more data collection or more data analysis is needed. So that's what I would say to that. I'm not sure if Catherine, you have anything else to add there.
Yeah, I totally agree. And I think that's one of the things that sort of a feminist approach can offer is a prompt to pay attention to absences and silences, like a prompt to give those things attention and make those absences and silences the objects of study. So I really like that a lot, because I think it's a really useful object of study to do a survey or an inventory of the data that are available, and also demonstrating to the research community how much knowledge we're losing out on, and how our results, if they are based in Western countries with certain kinds of data collection protocols, and we have no data from other places, just how much it's impacting our results and making them not generalizable to other contexts and places. And we didn't talk about it a lot in the talk, but I think this power dynamic that the commenter is bringing up around like sort of global north, global south, is a very real power dynamic, and particularly when it comes to the data question. So I think the pointing it out is important. And then the other strategy, which I think could potentially prove interesting, would be partnering with citizen science groups if those exist. So there was a PhD student in my department who was doing work, for example, with citizen groups collecting data about air pollution in Nairobi, and sort of trying to deploy these cheaper measurement instruments. So they're like sort of not So they're not like the highest quality scientific measurement instruments for air quality, but trying to deploy those in more locations across the city, and then thinking about ways to interpret those results or characterize those results, even though they might not be collected with the most robust standards. Sort of like do what we have with what you've got, but also using maybe statistical quantitative methods to then impute the error or the gaps. Again, sort of pointing attention to like, what is the range of things? If we think it's, the pollution's like between this like very wide range of levels, so at least we can say something about it. And yet, if we have more, if we had more data infrastructure, we would be able to do more and say more with more precision.
These are all great. And there's been an active chat going on inside the moderator chat. Some of the questions that we didn't get to, I'm going to say we're going to get to during the fireside chat, but we've been very firm about, since we all have been spending too much time in the Zoom world, to make sure everybody gets a chance to have a bio break. So you have your 4-minute bio break at this point. We'll be back at 11:05 and we will start back up. There were some questions about how all this connects to the weather and climate. I think people started to see those connections, but that's what we're going to talk about next. So we'll see you all in 4 minutes. All right, everybody, welcome back. And as promised, we are going to talk about putting this all together. So we are going to talk about the need for considering ethics in developing trustworthy AI for environmental science. And Imme is going to start first. Well, this is a joint talk between the three of us, so we're going to be switching back and forth.
All right, so this is a joint presentation by Amy McGovern and Bostrom and myself, Imme Ebert-Uphoff. So we're trying to tie together everything. If it wasn't clear before, there are lots of connections between what's happening elsewhere with AI algorithms and what's happening with weather and climate science. So as we know, if you look at AI algorithms being deployed in society, there are plenty of problems already. So AI algorithms already affect all aspects of our lives, and there are many positive consequences for sure, but there are also many unintentional bad consequences of AI use. And I won't go through the examples, you've seen enough before. One thing that's for me always shocking is that algorithms have been used in the US for over 10 years to estimate the risk of a person to commit crime in the future. So judges actually, when they decide sentences for people, they often use a little AI algorithm that tells them how likely people are to commit a crime in the future, and that's taken into account for their judgments. So, and there's no proper validation of such algorithms, no transparency. If you want to read more, look at the article in The Atlantic on should we be afraid of AI in the criminal justice system. But our key point is just, okay, we see all these problems happening elsewhere where AI is being deployed. And now we're pushing for more AI use in environmental sciences. Let's be smart. Let's anticipate and prevent similar problems in environmental science before they even arise. So that's why we're here, to learn from what we've seen in other areas and what we shouldn't be doing here. So for us, it's kind of a moment of, okay, if we don't do it, then who does it? And if we don't do it now, what are we waiting for? So since many of us are involved in the NSF AI Institute for Research on Trustworthy AI and Weather, Climate, and Coastal Oceanography, we keep on thinking, if we don't address responsible use of AI for the environmental community, who will? And I'm not saying others aren't, it's just like, okay, let's push more for it and let's be one of the leading forces to do this. And that's why we're here today. If you saw the sentence, if not us, then who, and if not now, then when, I took that from Yep Sanyo's speech at the 2012 UN Climate Summit. It's a great video excerpt. If you want to click on the link down there, I'll put it in the chat later. It's a 2-minute video on how he's making a real statement about we should do more about climate change. And in our case, it's not about climate change specifically, but about equality and the ethical use of AI for climate and weather and generally environmental sciences. Okay, so what are potential problems of using AI in environmental sciences? We saw a bunch of things already suggested in the chat. Here's some potential problems in environmental sciences, and that's not an exhaustive list. And there's also a lot of overlap between those, but we're just going through those 4 different types of cases here, just to give you an idea of things that can go wrong. And if you can think of additional problems, please put them in Slido. So problem number 1. Quite often our input samples are not representative of the entire population. And I will first give you an example from something that's very different in the application, and then we will see how that applies to weather and climate applications. So an example that went through the AI news like a wildfire in 2020 was an algorithm that took a low resolution image of a face and tried to restore the original face. So you're starting with a high resolution image, you're downsampling it, you're feeding it into this algorithm, and it tries to come up with original images. So let's see what could happen. So if you look at this picture, you can probably guess who that is because you've seen this person in the media quite often. This is President Obama. They took the picture, they reduced the resolution, fed it into the algorithm. Let's see what happens. Oops, we're getting a nice white guy out of it. The algorithm took the Obama picture and said, I think this is what the picture looked like at the beginning. Okay, let's look at some other examples. So here is the blog author who was talking about this, and he fed his own image in there. So on the left side, you see the original image that's downsampled and it's fed into the algorithm, and then on the right-hand side, you see what comes out of it, a nice white guy. You feed in a picture of Ocasio-Cortez, who clearly is Hispanic. You downsample it, you feed into the algorithm, out comes a nice white woman. So what happened here was really not intentional, but what happened was simply, and let me go back once, that this was again, so a specific type of neural network. It was just trained on mainly Hollywood folks, and most of them are white. So it was totally unintentional, but you should have anticipated this a little, right? So let's try not to make the same mistake and just feed in data samples that are not really representative of the entire population, because the algorithm will then think, oh, everybody's white because that's all I've seen. So I'm going to reconstruct all images to produce white people. What are the patterns in environmental science? So for example, there might be unusual meteorological conditions, like extreme conditions, and by definition, they're not usually well represented in data samples. Some things might not be represented by sensors because it's in remote mountain areas, over oceans. You may only use the visible bands of satellites. We may only be looking at the northern hemisphere. The southern hemisphere tends to be underrepresented. So there are lots of consequences if we then use that data to train our neural networks or other machine learning tools, because those scenarios that are underrepresented in the machine learning model are going to be underrepresented also in the results. So you get unintentional environmental justice. And with that, I will turn it over to Amy for more specific examples.
Next slide. So we're going to give you a couple of examples of places where in weather and climate, although primarily in weather data, we already know about some of these biases. That was part of the reason I asked the question during Catherine and Lauren's talk about other data sets, what data we might not be collecting. These are data sets that we know we've collected and we know the biases exist. So we're going to start with this one. It apparently, if you look at only the collected hail reports, it apparently only hails where there's people and highways. Does anybody believe that the hail that comes down from the sky is actually concentrated only on the highways and where there's people? Do you think the hail might be a little bit more uniformly distributed? So I'm going to guess you're going to, I know I can't get interaction here, but I'm going to guess you're going to say, yes, it's probably not distributed along the highways and the cities. The problem is, if we train our data on these hail reports and only these hail reports, what might our algorithm do? Our algorithm may not be doing the environmental justice that we're talking about, because it may be predicting hail is only happening in cities and highways. So we need to be able to know that this data has biases so that we can account for it. Next slide. There we go. Say, wait, you jumped 2 slides. So it's not just hail data. I just grabbed another data set. This is another well-known phenomena. Tornadoes, it's been a long morning. Tornadoes also have reporting biases. Again, if you get a tornado, let's go with the, sort of if the tree falls in a forest. If the tornado happens in a field where it didn't knock down any structures, does it matter? Well, yes, it does matter, because if your algorithm is trying to learn from all the tornadoes that are out there and you only have the tornadoes that people reported, you turn out to have the exact same kind of population bias as you have with the hail data. And this is from a different paper that came out relatively recently. And they talk about ways that you might be able to correct this bias by putting Bayesian modeling on top of it. And it's an interesting approach, although will it work for every data set? I don't know. It's just, it's critical to know that these biases exist in all of our data. Next slide. So this one's a little bit different. This one went through Twitter also like wildfire. It went through the weather Twitter community. And I thank Jack Sillen for creating this graphic. This is a graphic showing the coverage of the WSR-88D radars, so the Doppler radar network that's across the United States. And in the background, showing the counties that have a more Black population in the Southeast. And what's interesting out of this graphic is that the higher the Black population, the less coverage there is by the WSR-88Ds. Now, when this went through Twitter, there was a lot of discussion of, oh, this was never on purpose, blah, blah, blah. I'm not even going there. I don't think this was on purpose, but I'm not going there for that discussion. What matters for the discussion we're having, very much related to the previous talk, is this is the data we have, right? And if we're trying to make really good predictions, we need to know going into it that we are missing data in some of the underserved communities. And if we want to make our predictions good, we need to know that that data may not be there. And that if our tornado algorithm relies, for example, on being within the excellent radar coverage area, then we have a whole section of the community that we're missing and not doing environmental justice, because we may have trained our algorithm unintentionally to only predict the tornadoes in those sections, and we don't have the sensors there. And if you, by the way, don't want to believe, I think I'm mostly preaching to the choir here, but if I'm not, if you just look at this and you say, no, our algorithm's going to work anywhere, then think outside the United States, because they don't have the radar coverage network that we do. And how can we create algorithms, not just for tornadoes, how can we create algorithms for any of the problems we're doing that will work everywhere? This was brought up in the previous talk by talking about how the fact that much of the data is Western biased. Next slide. So problem number 2 that we're going to talk about is related. It is the idea, so that was sort of bias within the data, but the data was already there. This is a related problem where we might have problems with the labels themselves. And we had originally started talking about the coded bias problem, and then there's a coded bias movie that just came out that's on Netflix, which we highly suggest, but we're going to jump into weather examples for this talk. So the idea is not just that the data that we're collecting from the humans is biased in the sense that there's bias towards the highways or the population centers, but there's also particularly human biases that might just come into the data. So let's talk about what those might be. Next slide. Oh, I thought I had examples on the next slide. Well, I'll do this and then we'll go to our examples. Questions we need to ask ourselves about this data and the human biases. You know, who's labeling our data? That really matters. Is it meteorologists labeling our data? Is it the general public labeling our data? Does it matter for what kind of data we're trying to collect? It might be the case that we need more data from the general public, but we need to acknowledge that the general public, as you'll see in some of the future slides, potentially has biases because they're not trained necessarily. This isn't a bad thing. This is just that we need to acknowledge that the data comes with these biases. We need to ask how we're collecting our data. Could our data exclude people in less populated or remote or low income areas? If we're collecting data from sensors that cost a lot of money, but they're like personal sensors, right? Personal weather stations, for example. Are we likely to have a high density of those in the low income areas? Probably not. So does that affect our weather collection and or does that affect our AI algorithms? And finally, we need to really increase the diversity in our data collection and our decision making in our group. We need to make sure that this is the, I actually took a screenshot of the slide from this morning, and I was going to stick it in, but I didn't want to edit my slides right before I talking about how the data feminism view of making sure we include everybody that's affected. Next slide. So let's give you an example of some places where the data is ugly because of humans. And this isn't, it's just humans. We're humans. This is an example of hail data, and this slide comes from a talk from John Allen. Hail data is ugly. What does that mean? When you report hail sizes, you report it based on common object sizes. And as it turns out, for example, people don't really know what a teacup is. It's one of the common object sizes, but nobody drinks tea out of a teacup anymore. And so that doesn't get reported as frequently. What you see are golf ball, baseball, and softballs showing up in spikes in the data. And then John has 2 graphs here showing how you bin the data also dramatically affects what you're seeing in the data. And we need to know that if you're just going to grab the hail reports and you're going to use that to fit a distribution, that the distribution is probably not exactly representative of reality, because it's probably not likely that the hail comes down in discrete object sizes. It's more likely the case that you're looking at these and you're saying, oh, it looks like a golf ball. And you don't jump to the next size until it gets to, oh, that looks like a baseball, right? Next slide. Because I've been giving you only severe wind and tornadoes, I want you to believe that it exists in other places. I admit I didn't find graphics outside of the severe world, but this is one that I found really fascinating. They stuck a whole bunch of people inside a wind tunnel, and they had them predict what wind speed they thought they were observing. And they compared that to what the actual wind speed was. And this is the top graphic. Humans stink at this task. So if you're asking your humans to report the wind speed and you're not using objective measurements, you're going to get really crazy wind speeds, and they're not going to be very good. The humans tend to overestimate it. You'll note, by the way, if you're paying careful attention to these graphics, that the X and Y axes are not equal. This is not a linear, y equals X line there. Okay, so if that graphic alone is not enough to convince you, we look at the graphic on the bottom. The graphic on the bottom is all the reports from humans compared to the observations. And as it turns out, the human reports are very conveniently binned into 5-mile-per-hour bins. So if you look at the observations, they're much more of what you would expect, a nice smooth distribution, right? The red, which is the measurements, is the very unsmooth distribution. And if you're trying to train an AI algorithm on all of this, you might be doing things that don't work unintentionally. Again, we get back to the radar. The radar placement was, I'm sure, not intentionally excluding people. All of this, however, is the data we have. And it is the data that we have to live with. And so we need to be able to understand that these biases exist in our data and move on and do better predictions with our AI algorithms. And I think that's my last slide, but go to the next one and I'll see. Oh, I have one more and I can't forget that I forgot the slide. One of the things that we talked about yesterday when we were talking about making sure that AI was robust is that they're in the traditional AI world, we talk about adversarial data. And typically when you explain adversarial data to people in the weather world, they say, oh, there's no adversarial data in the weather world. That doesn't exist. Hold on. To quote people, hold my beer. You know, their adversarial data does exist in the weather world. So this is an example from MPing from last year, which is a fabulous crowdsourced data set. MPing is used by meteorologists to check on the weather reports. Somebody hacked into MPing yesterday and falsely reported an outline, not yesterday, last year, and falsely reported an outline of the state of Alabama. It got worse from there. I don't have graphics from that because the graphics got much, much worse. They got shut down. They have been stopped. But, you know, are we getting other kinds of adversarial data like this? When we look at crowdsourced data, could there be other ways in which our crowdsourced data is being deliberately falsified? Could it be the case that you have one little tree limb down, but somebody reports whole tree down, right? It's just that they're in their sort of human tendency to exaggerate. That might be deliberate, it might not be deliberate. How does that affect our algorithms? We can't verify every single weather report that's out there. Clearly, this was so obvious that it got thrown out. But what if you just, you know, subtly throw in something here and there? How do you know if that is adversarial data, and how do you know how that's affecting your algorithm? It's something we really need to keep in mind. And now I'm positive that's my last slide.
Yes, it is, which means it's my turn again. So problem number 3 is really highly related to the previous 2 we had, but it's just a great way of showing what can go wrong. So we're going to talk briefly about the so-called clever hand strategies in machine learning. And those of you who know me know this, so I apologize if you've already seen this, but for everybody else, it's just a great demonstration. So we're going to show you examples from the paper that's cited here, and all the images come from that paper. It's not our work, it's their work. And the considered task is object recognition. So they use an AI algorithm trained to detect many different objects and images. And the AI method they use is a neural network. And the specific task that they're analyzing is, how does the neural network decide whether there's a horse in an image? Which strategies does it use to decide? So the method used for analyzing the strategies is called layer-wise relevance propagation, but that doesn't matter here. The key point is that this method that they're using takes its input images over here and tries to decide whether there's a horse in an image. But in addition to the image, it also generates its attribution or heat maps that show you where the neural network was paying attention when it's deciding whether there's a horse or not. So just look at this image up here, and the algorithm decided that there is a horse in the image, but look where it was looking. It was mainly looking at the poles. So the neural network actually learned that in the images that it had seen for training, whenever there were poles of this sort, there was a horse, which of course is a faulty strategy, because if you ever have an image that has poles and no horse, you would still conclude that there's a horse, and that's wrong, right? So that's a bad strategy. And another one that you already saw in Wendy's talk, I think on Monday, was here they had images and I didn't realize that they had HTML text at the bottom. And so the algorithm became really good to say, whenever the specific HTML tag is there, I know there's a horse. So if you look at the bottom here, you see that the algorithm learned to look at the HTML tag. And if you took the HTML tag out and fed the same image to the algorithm again, it wouldn't detect the horse at all. So again, a faulty strategy, which would lead to false negatives. So what happened? Well, our AI algorithm learned what's called a clever hand strategy, which just means that it exploited correlations that were in the training data. So, you know, the algorithm did what it was supposed to do. It was given data and used all the clues it could to figure out when there's a horse and when there isn't in these specific images. And the problem really wasn't the algorithm, the problem was the data set. But you need to make sure that if you have a data set that has these correlations in there that weren't meant to be in there, that you detect this, because many correlations are present in the data, but not representative of the real world. Coming back to meteorology, large hail, many report in highly populated areas, is a perfect example. So a neural network would probably learn pretty quickly, given the hail data that Amy was showing before, it would probably figure out pretty quickly, oh, only highly populated areas have hail, right? So the key point is, using neural networks as black box is not a good idea. We need to better understand what the neural network is doing, but we also need to make sure that we figure out what biases we have in the data. With that, I will turn it over. Oh, no, we have one more slide. So problem 4, and this is just a very brief one, is We need to be careful also that AIs are really good at faking and at playing games with our visual recognition. So if you take the example of generative adversarial networks, there's a special type of neural network that is particularly good at generating very realistic looking images and videos, etc. And GANs are starting to be used in meteorological applications, for example, to increase the resolution of satellite imagery and to create forecast imagery with intricate small scale features. The troubling thing is that it can often generate images that look incredibly real but aren't actually that accurate. So we need to just be careful and make sure we don't trick forecasters with techniques like that. And so that's a whole nother topic. With that, I will pass it over to Anne, who will talk about different frameworks for ethics to combine with XAI, explainable AI.
Thank you, Imme and Amy. So I'm going to introduce three different perspectives from moral philosophy: consequentialism, deontology, and virtue ethics. And this is work that's borrowed from Michael Lamb's work on the ethics of climate change communication. And I'll provide a reference at the end. It's from the Oxford Research Encyclopedia of Climate Science. Michael Lamb has worked quite a bit with Melissa Lane on these issues of science communication and climate change communication, and his work on ethics, his and Melissa's work is highly worth reading. So consequentialism, the first of these, of which utilitarianism is perhaps what you've heard of, and perhaps the best known flavor, evaluates actions as morally right or wrong according to their consequences. Is the net benefit positive? What are the effects and effectiveness of the explanations? Consequentialism is extremely popular in policy and many other contexts, but some people argue that it overemphasizes effectiveness at the cost of ethical considerations. Deontology, on the other hand, means duty or obligation. So it evaluates actions by their conformity with moral principles or universal moral principles and rules or duties. And virtue ethics, coming from Aristotelian virtue ethics, emphasize what's right to do. What are the right actions that are important to achieve human well-being, to make sure that we flourish as a society? Next slide, please. So consequentialism has basically five different parts here. It determines moral rightness or wrongness in light of a communication by its contribution to a further end in this context, or telos, such as utility, happiness, flourishing, or welfare. So it's teleological. It's forward-looking. It tends to ignore historical rights and responsibilities, which, as you can guess from the previous conversations that we've had today, is problematic in the context of communications and even communications about AI. Its consequentialism is maximizing rather than respecting value per se, and it's aggregative. It calculates the greatest happiness for the greatest number, and that's how the determination is made whether something is ethical or not. Consequentialism on the plus side is also impartial and treats everyone equally, so it has several positive as well as potentially problematic features. Next slide, please. So in general, the prediction of consequences is extremely difficult in the environmental sciences. Consider the uncertainties, for example, around climate change. Even removing this to the prediction of consequences of communicating about AI remains difficult, because those communications can in turn affect actions based on environmental expectations that are derived from the explanations. So environmental consequences are nearly impossible to measure on the same scale as well. Measuring the consequences of XAI in the environmental sciences will be similarly challenging. And further, consequentialism fails to account for other moral considerations, such as backward-looking causation and responsibility, or present-focused duties or virtues. So we can ask ourselves, in the context of XAI, should ethical XAI communicate only in ways that maximize the best consequences, so take a consequentialist perspective, or should ethical XAI also consider what is owed to audiences, to model users, and to decision makers as a matter of respecting their rights or agency? Next slide. And this leads us directly into deontology. This is often appealed to in the context of Kant's formula of the universal law, whether or not a specific principle is universalizable. So telling a lie, for example, would fail this test. If everybody did it, it wouldn't work. So blurring persuasion and manipulation creates distrust. So it's important in the context of any kind of science communication, but particularly in XAI, to be clear about this distinction. The potential epistemic inequalities between scientific experts, policymakers, and the general public also pose a challenge. The highly technical and often inaccessible nature of AI presents not only practical challenges when communicating with lay audiences, but also ethical challenges depending on how experts and audiences treat those with different levels of expertise. And so here, this distinction is that persuasion is a way of presenting ideas, arguments, and appeals in such a way that the audience is enabled to make an autonomous judgment. And so this is why these epistemological differences are really important. This is distinct from manipulation, where you're trying to make appeals in a way that prevent audiences from having the information they need to make rational judgments and act autonomously. And so Lamb argues that an appeal to respect for autonomy provides a way to distinguish persuasion from manipulation in a way that simple appeals to consequences or consequentialism do not. As you will have inferred from Catherine and Lauren's presentation, this is not a simple distinction to make, and it's not clear that you can be an effective communicator if you don't appeal to emotion. It's also not clear that you can appeal to emotion and still enable people to make an autonomous decision about, for example, the trustworthiness of the AI that they're looking at. Next slide, please. So Kant's formula of humanity then highlights that you want to respect the dignity and rights of people and the rational capacity that people have to make autonomous decisions, which confers dignity. So communicators, and particularly the explanations in the context of AI, should be laid out and act in ways that respect the autonomy of others' wills. And here it's often highlighted that lying is wrong because it fails to respect others' rights and dignity as persons, and it doesn't inform autonomous decision-making or consent. So Lamb does make a distinction between the indirect role of values in influencing decisions about uncertainty and risk from the direct role of values in supplanting or disregarding scientific evidence, and the importance of the role of trust in all of these communicative aspects. Next slide, please. So 5 principles for XAI emerge from deontological ethics, and this is taken from Cohen's work with Melissa Lane and Oppenheimer. Next, there's a bunch of animations here. Maybe we could just go through them, Emma. Yeah, so the first is that honesty is a, thank you. You might as well go a couple more here. Thank you. Deontological imperative. So the remaining 4, these 4 shown here: precision, audience relevance, process transparency, and the specification of uncertainty about conclusions. Next, Emma. These are all hypothetical imperatives. They're principles that direct people who are communicating toward the instrumental goal of persuasive communication that's accessible and accessible, so that it can be evaluated by its audiences. And the 4 above next are subject to trade-offs. So you can think about the fact that if you want to be precise in your communication, that may mean that you are not as transparent because you're communicating a lot of complexity. You want to specify the uncertainty about conclusions that may obscure transparency as well. So however, honesty is not subject to these trade-offs. So it's easy to see how these principles 2 through 5 apply to XAI, but what you might ask yourself is honesty in the context of explanations for artificial intelligence. Next slide. So onto virtue ethics, there are many virtues, and unfortunately, I think there are a lot of animations here too, Emma, so we might as well go through them. There's justice, truthfulness or honesty, courage, patience and persistence. Keep going, there are a couple more here: magnanimity, and we have temperance and humility and practical wisdom. So and you've got 2 more animations here, and then we'll stop on the bottom of the slide. Great, so let's hold here for a second. So according to Aquinas, justice is the virtue that regulates our external actions and relationships with other persons. So for this reason, it is one of the most important virtues for communicators. And related to justice, truthfulness and honesty dispose a communicator to share the truth properly across a wide variety of circumstances to a wide range of audience. Patience, persistence, and magnanimity can help communicators maintain resolve in the face of difficulties. And just thinking about communicating honestly and transparently about AI, this is a lot of difficulty. So to apply virtue ethics for ethical XAI, consider the following. be honest, be transparent, do not be manipulative, dishonest, or deceptive. And so you don't want to say that the AI is doing something it's not, or say that you know what it's doing when you don't know what it's doing. Consider what a virtuous communicator would do. And here it might be important to think about who could you emulate in the context of ethical XAI. And there are important developmental roles in this context of social practices within the, for example, the community of those who are practicing XAI, emulating virtuous others, for example, Imme and Amy, learning from personal experience and community trust and accountability. These are all super important in the context of applying virtue ethics to the communications in the context of AI. Next slide, please. So if as an artificial intelligence for environmental sciences researcher, you know what is just or truthful, but you're not courageous enough to challenge popular opinion or to tell difficult truths, justice will not be done. So it's up to you. On the topic of virtue ethics, we can ask ourselves, does calling for ethical XAI fall into the one known downside of virtue ethics, that is calling for communication that does not offer a clear formula and lacks concrete guidance? So if that's the case, how could or should calls for ethical communications and explanations of AI be made clearer and more concrete? And I'll leave this as an exercise for the reader. Next slide. So what are the risks? And I'll conclude on these few points. What are the risks if the model produces a misleading or wrong result? And those are really important to consider in the context of consequentialism, for example. Do your explanations of AI convey sufficiently any uncertainties about what the model is doing and how trustworthy the model is? It's important as a communicator, and science communicator, and an environmental science communicator in particular, to consider the lessons from all of these: consequentialism, deontology, and virtue ethics, and to evaluate explanations of AI in light of these moral considerations. And I believe the next slide is Imme's or Amy's.
Well, I think we should take questions because we have 3 minutes till the next talk. So
okay.
But I can briefly, while the questions are getting brought up, I can say that there is a call for papers on looking at ethics for AI, and then there is a brand new journal coming out for which I guess I should turn my camera on. There's a brand new journal coming out from AMS, and the announcement was supposed to go out publicly yesterday, and it hasn't yet, but it is coming. And responsible and ethical AI for environmental sciences is one of the topical coverage, as well as just AI for environmental sciences in general. With that said, let's tackle some of the questions. So Imme, you want to turn your camera on too? And we can answer this first question that seems to be highlighted. Is there any risk of such discrimination in the climate model? I would say yes. I actually have been in the questions and I saw the reply, and I would agree with Douglas's reply, which was that, we don't, the reason we're bringing this talk up is that we really want to make sure that we're understanding that the biases in the data can lead to biased predictions. And if you're getting, it's garbage in, garbage out. If you're getting data that's not good measurements in some places, then your predictions might not be great in those places as well. So we may end up with biases that are definitely unintentional. Anne and Imme, do you want to add anything to that?
I'm not an expert on that, but I would bet that the models are better, for example, in the Northern Hemisphere than they are in the Southern Hemisphere, just because there's more data. Because at some point, when you develop a climate model, there's a lot of tuning going on. And you tune it to observations. And again, if your observations aren't unbiased, then you get bias in your climate model even.
And I think we have time for one question, then we'll introduce Francesca. Do you want to pick a question, Anne, since you didn't answer?
Well, I was going to answer to that one.
Okay,
I
go
just
for it.
add a point to that. So people are trying to use downscaled climate models for regional impact predictions. And there you see all kinds of problems, right? Because as soon as you have data that don't allow you to downscale in certain areas, or and the uncertainties are so great, it's really hard to be ethical about communicating equally what the impacts are in different areas. It's currently not possible. So do we have time for one more question? How about
Probably not really. It's 11:40.
Okay.
We need to introduce Francesca.
There we go.
We will come back
Okay.
to some of these fabulous questions during the fireside chat.
Yes. Thank you all. And it's my pleasure to introduce Francesca Rossi, who we're delighted to have with us here today. Welcome, Francesca. Francesca is an IBM fellow and the IBM AI Ethics Global Leader. She's an AI scientist with over 30 years of experience in AI research, on which she's published more than 200 articles in top AI journals and conferences. She co-leads the IBM AI Ethics Board and actively participates in global multi-stakeholder initiatives on AI ethics. She's a member of the board of directors of the Partnership on AI and the industry representative in the steering committee of the Global Partnership on AI. She's a fellow of both the Worldwide Association of AI and of the European one, and she is also going to be the next president of AAAI. So welcome, Francesca, over to you.
Thank you. So let me share my screen, show my presentation. Okay. Okay, so this talk will be more, I mean, not the overall talk will be specific about climate or environmental science, but it will give you an idea of how in IBM we put together the whole framework about AI ethics and what we call trustworthy AI. And what we mean by that, and then I will make some examples related to environmental science, and in particular the weather data, because as you know, IBM has acquired the weather company some years ago. So as you know, and I've seen, it has been presented, but AI has a long history. More than 60 years in the making. It is a discipline that includes many different techniques to solve problems. Some of them are based on the availability of large amount of data, like those that we call machine learning, and specifically also those that are called deep learning. But other techniques are instead not really based on data, but based on algorithms that are reasoning algorithms that take the given problem and find a solution to the problem by reasoning about the problem, making inferences, using logic, and so on. So these algorithms are put together and defined by people who then code the algorithm into a machine, and so that the machine can solve the problem in that way. So, and these two kinds of AI kind of techniques, the first based more on logic and reasoning, and the other one based on data and machine learning, coexist in AI. Sometimes are combined, especially in recent times. But as you know, the machine learning algorithms and techniques are very successfully used in recent years because they allow machines to have these so-called perception capabilities. So to interpret with some accuracy what is in a piece of text, what is in our, what we say, so interpret our commands or our vocal commands, or even to interpret, images, videos, and other things that otherwise, without these data-driven algorithms, were not successful earlier on. And in these kind of algorithms that may generate some questions and concerns, as we will see a little bit later. So with all these techniques combined together or used separately and so on, AI right now is really pervasive in our life. There are a lot of applications. And here is a slide that just tells you that how come that machine learning algorithms were already there in AI since the 1980s, but have been used only recently. And the reason is very obvious, that they need a lot of data. And also they need, since they need to analyze and look at a lot of data, they also need a lot of computing power to handle that data. So now we have those two things. In the 80s, we didn't have them. So with all these algorithms, now AI has capabilities that previously did not have. And some of the times these capabilities are even more accurate than human capabilities. For example, these are two examples that relate to image captioning. So the generation of a caption that describes what is in an image. Already since 2015, machines are have a smaller error rate than human beings. And the other on the graph on the right is about interpretation of vocal commands that already since 2017, machines have a smaller error rate than human beings, the human level that you see here. So these capabilities gave rise to a lot of different applications. Some of them are more consumer-based, some of them, others are more business-oriented. For example, and this is just a very, very incomplete list, but I'm sure you can relate to many of them in your everyday life. IBM is more on the business to business delivery of AI. So we deliver AI to other companies that then use it in their operations or to provide support to the decisions of their professionals. But there are also, as you know, many other companies that have instead the business to consumer kind of business models. So they develop AI within their operation to provide better services to their users. So AI has a lot of capabilities, I would say, but it also has a lot of limitations. Some limitations are related to the fact that AI is very narrow. It's called narrow AI, means that it can solve very well a very well-defined problem. But as soon as the data distribution changes a little bit, it may not behave that well. So it's not robust in some sense, and it's not adapt well to other environment, other situations. So here, for example, you see the image on the top left of a stop sign that is interpreted correctly with 99% confidence, but another stop sign that instead is just a sticker on top and instead is interpreted with high confidence as a completely different object. Other examples here are about stop signs, are about speed limit signs that are interpreted as stop signs or as a speed limit sign with a different limit, or again, other examples where a panda is recognized instead as a gibbon with a very high confidence as soon as there is some noise combined with the original data, as well as other ones. And notice that all these models, all these algorithms that have these limitations, they have the limitations despite the really huge amounts of data and computing power that are put in place to develop these algorithms. So here you see, for example, a chart describing the number of parameters of these neural nets that provide these capabilities, which recently they really have exponentially grown. So that means that these machine learning approaches are very successful for some things, but they have inherent limitations. And that's why many AI researchers are studying ways to go beyond this approach to overcome these limitations. So we have capabilities, we have limitations in AI, but also we have some legitimate ethical considerations about the impact of AI on our life. These are some examples of that I'm sure you have heard of about AI-based services or products that were shown to have some ethical issue, especially related to discrimination or some usage of data usage. So I'm sure you have heard of them, but as you see, and these companies, of course, did not anticipate having this issue. So that means that we need to be, with time, we have been actually more and more proactive in, as was said earlier, anticipating these issues and being more careful about looking at our data and what is hidden in the data, so that we can anticipate possible discriminating behavior, for example, and to detect it and mitigate it, and being transparent about it. So overall, a lot of the discussion in AI ethics has to do with the notion of trust. So can we trust whatever decision or recommendation that is made by a machine? In this case, I put the cartoon of the so-called trolley problem, where an autonomous car has to decide which way to steer, given that in any way is going to harm somebody, whether they are the passengers or the pedestrians. So in some way, the cars have to make autonomous decisions in this particular case. But even if they don't make autonomous decision, but they just support a human being by providing recommendations for the human being decision, then still the notion of trust is really fundamental. So overall, this AI ethics is a discipline, is is a field of study, very multidisciplinary. It includes AI experts, but also sociologists, philosophers, psychologists, policymakers, lawyers, and so on, which has a very simple goal: how to take the best out of this AI and minimizing the adverse outcomes. And one of the important things to notice is that the solution that this community puts in place are not necessarily only technical solutions. Actually, usually they are not technical solutions only, but they have to do with sometimes technical solutions, but also solutions that involve guidelines, best practices, policies, standards, auditing mechanisms, and many other non-technical solutions to really achieve that goal together with the technical ones. So here is one slide that summarizes the main AI ethics issues. So the first one is the fact that AI, as we said, especially machine learning, needs a lot of data. So data privacy and governance issues immediately are relevant here. Second one, this machine learning algorithm, although sometimes very successful and very accurate, they are kind of opaque in terms of understanding how they make the decision, how they get to their output given the input data. So then if you want to gain trust in a machine that is a kind of a black box, it means that you need to break this black box, to open it up, to make it explainable, and to also support this deployment of the machine with a form of transparency. So here I make a distinction between explainability and transparency. And I use this word in a way that I think is slightly different from what we used in the previous talk, because explainability is a property of the machine. The machine has to be able to explain why it got to that decision given the input data. Transparency instead is not the property of the machine, but is something that is on the developers team, on the ones that are delivering the AI, that have to be transparent in how this AI system has been put together, what's the appropriate use, what are the limitations, what are the tests that have been done, what are the results, the threshold that have been used for fairness, and so on. So the next thing is that AI, again, can make decisions or recommend decisions. So it is important to make sure that when it does that, it does it in a way that is aligned to our values. What are our values? There may be many different ones according to the specific scenario, but fairness and non-discrimination is certainly one of them. So that's why there is so much, around AI bias, and in order to achieve the form of fairness that is relevant for a specific scenario. There are also questions about accountability, because these machine learning algorithms, they are very successful, but they always have a small percentage of error, not because somebody made a mistake, but because they are statistically based. And so it's inherent that they have a small percentage of error. So what happens if the errors are actually occurring? Who is accountable for the mistakes? Who is in charge of compensation or responsible for them? The next one is about, again, manipulation and profiling of people, which can impact on human and moral agency. And then, of course, there is a more general questions about what's the impact of this misuse of possible AI in our society, because since AI is pervasive, then the impact is going to be very large, as well as the impact on jobs. And in general, where do we want this technology to take us? What's the vision of the future that we have? And so that we can use technology to in a trajectory that gets to that. So about fairness and bias, the detection and mitigation of bias, it's important to understand that the space here is very complex. First of all, because there are many different definitions of fairness. Here is a very incomplete list of definition of fairness: statistical parity, group fairness, demographic parity, and so on. And each one is appropriate for a specific scenario, specific deployment or use of this AI system. So it's already a challenge to understand for the developers team, for example, which is the notion of fairness that has to be considered and is relevant in a certain scenario. Once you have resolve that, and a multi-stakeholder approach should be used to identify the right one, then you say, okay, I'm trying to remove bias in order to get closer to that definition of fairness. But you have to define a threshold, because you're saying when is acceptable for me, because you're not going to achieve zero bias or 100% of fairness. So you have to define which is the threshold that is acceptable to say, okay, now I have reached enough, I am close enough to the notion of fairness. And now the next dimension is when to detect bias, whether in the training data, definitely, or in the model itself. So there are many different places where bias can be hidden or can be embedded, and then there are specific algorithms that allow you to detect or to mitigate bias of various forms. This is one example that was cited already in the previous slide about an algorithm that was used to predict recidivism by giving a low or a high risk of recidivism for people, to say whether they are a high risk of recommitting a crime or low risk. And this algorithm was one of the first one that was analyzed and was shown to have a form of bias between different ethnicities. And here is not, I put this slide because I wanted to understand that here, for example, it's a typical example where if you use two different notions of fairness, in one case, the algorithm is biased, so it's not fair, and in the other case is not. So it's crucial to really identify the right notion of fairness. If you look at just the average, the accuracy for these two categories of people, the black and white, then you see that the accuracy is the same, more or less the same for the two categories. So if you just look at this definition of fairness, you say, okay, the accuracy is the same, so it must be fair. But if you then look at the errors that are made, so the ones, suppose accuracy was, I don't know, 90%, so the other 10% of responses that were wrong, the errors, and here you will see like false positives and false positives, so people that have categorized as low risk, instead it should be high risk, and people that are classified as high risk, instead it should be low risk. So you see that the false positive and false negatives for the two categories are completely different percentages. For white people, you see a lot of false negatives. And for black people, you see a lot of false negatives. And that's where is the bias, but you only see it if you use another notion of fairness that looks at the errors and not just at the accuracy of the correct responses. The next one is about explainability. Of course, that a lot has been said already in the previous slide. This is just to mention that explainability is actually also a legal requirement in some regions of the world, for example, Europe, where the General Data Protection Regulation requires that there is an explanation, understandable, a meaningful explanation, so understandable by human being, about why a certain decision that impacts on human life, like denying a loan or some other benefit, has been. So let me go a little bit fast. So this is to say that but I think it should be clear about what I told you already, that AI is not a neutral technology. Some people say, oh, AI is like a hammer, then you can use it for good or you can use it for bad things. But no, AI has to be designed and developed with the right properties, besides the fact that you have to use it for good things and not for bad things. So it is really important to tackle these AI ethics issues, not just when the AI is ready to be used or deployed, but also while it is designed and developed and trained, we use with training data and test data and so on. So here is a slide about why should a company that builds AI or uses AI care about AI ethics? And you'll see that here there are many forces that contribute to that, fortunately, so that companies, for one reason or another one of this list, which is also an incomplete list, I think, they are, driven towards thinking about what to do with this AI, whether it's company values or the risk for the company reputation or the anticipation for new laws or issues about social justice in general or the clients demanding for something to be done about these issues or the pressure of the media or even business opportunities. Well, there are fortunately a lot of different reasons why a company should look at this AI ethics. So at IBM, we started already several years ago in 2017 to say, okay, what are the main thing that we want to do with this AI? And so we said, wrote down this principle of trust and transparency to say that the purpose of AI for us is to augment human intelligence, not just to go in its own independent way making decisions. The data belongs to whoever is giving us, to the client who is giving us the data, also whether it's a hospital or a government or an airport or whatever. And the emphasis on transparency and explainability in order for making sure that we communicate to enable, as was used in the previous talk, to enable whoever is using or whoever is buying AI, whoever is using the operator that is using AI to make the best decision supported by the technology. Then you will see that here that we use the notion of trust, but we didn't really say here in these three principles what trust means. So the next thing that we did, we said, okay, what do we mean by trust? And we decided to spell out this notion of trust into 4 pillars. One is fairness. One is explainability, so no black box. One is robustness and one is transparency. So to follow what was said in the previous presentation, fairness is about really how you want the system to behave, as well as robustness, while transparency and explainability are how you want to build the system in terms of explainability and what you want to do as a developer and the builder of AI in terms of transparency in order to communicate correctly and transparently the limitations, the capabilities of this AI and the possible risks. So this is already said. So let's look at the issue of fairness, to go back of the issue of fairness that we said. Again, here at IBM, just like I mentioned earlier, we put together not just technical solutions to detect and mitigate bias, and we put together them, both open source libraries like the toolkit called AI Fairness 360, but also proprietary, algorithms like what is called, the name is Watson OpenScale. But these are technical solutions that allow to detect and mitigate bias in the data sets, in the models, and so on. But then we also complemented these technical solutions with a lot of educational and training initiatives, where there is mandatory educational modules for all IBMers and more specific ones for developers, but not just educational modules, a lot of design thinking sessions to really change their frame of mind and to make them understand, what it means bias for their specific project, the product that they're building. Also to help them understand what it means to use a multi-stakeholder approach, to communicate with the client, to understand what it means for them, the relevant notion of fairness, as well as to give them methodologies to adopt and use the toolkits and to adopt new processes in the developer pipeline in order to detect and mitigate bias. Because in their previous developing pipeline, those processes were not there. So we needed to make sure that these new processes were easily integrated in what they were doing already and adopted in the most at scale. And then we put together a lot of governance around it so that we make sure that in an enforcing way, but also in an enabling way, we allow really the best adoption for this thing. Another thing that we did, we also especially related to AI bias, is to try to make these developers teams as diverse as possible, because by diversity in the team, the people can recognize each other biases and then can better tackle this issue. The AI transparency, as I said, is very important for us. We also build an open source toolkit called AI Fact Sheet 360, which is describing the concept of AI fact sheet, which is just implementing this idea of transparency by documenting all the design and development choices that have been made, and to be useful for developers themselves, but also for clients, for regulators, for auditors. And this is an idea that we implement with the AI fact sheet, but similar ideas are in other companies and also in by policymakers like the European Commission. And then we build this governance on top, the AI ethics board, that is useful for awareness coordination. It has representatives for all the business divisions of the companies, helps developers as I said, to educate them, to train them, to give them the right methodologies, but also it helps the offering teams to understand whether an offering to a client is aligned to our principles or not. So we develop a whole protocol to communicate with these various offering teams. And then when there are offerings that raise some ethical questions, we bring it to the attention of the board that together with them tries to understand if the offering is okay, or whether we need to put some contractual conditions in the contractual agreement with the client to make sure that that offering can move through. And then we have a lot of partnerships with academia, with other companies, even our competitors, with governments, with civil society organizations, because we think that really the multidisciplinary and especially multi-stakeholder approach is the only one that can help everybody understand what are the best practices to tackle these issues. So that's why we really work a lot with all these other stakeholders, and then of course each company has to understand in his own business model, his own scenario, what it means, for example, to detect and mitigate bias in the AI that is producing, and the solution, possibly the tools, will be different, but at least the best practices and principles should be shared and can better understood and even identified together with other stakeholders. One example is that the issue of AI bias was not identified by AI researchers or AI developers, was identified by other social science people who went and analyzed the behavior of some AI algorithm. So that also is an example that multi-stakeholder is needed in order to even identify the issues. So to give an example related to in particular to the weather data, of course, weather data can have bias, as was mentioned already, because we rely, of course, on data coming from sensors, and sensors are not equally dense in all the regions of the world. Usually in the US, in Europe, they are more dense, they get more data than, for example, in Latin America or in Africa or in other countries, in less developed countries. So you have less data, and also the data, sometimes the sensors are less accurate. So for example, in some regions of the world, you have radar, in other regions you don't have these kind of sensors. So then we put in place to enable to have a good quality forecast, weather forecast for all the regions of the world, not only those where you have a lot of sensors with a lot of and very accurate. If we put together all sorts of techniques to try to mitigate that difference in accuracy in weather prediction. So some of the techniques are related to using interpolation between different sensors that may be not close to each other, but also others rely on taking analogous regions where you have a lot of data in order to infer predictions in regions that where you don't have a lot of data. So these are two examples. So there are a lot of ways that we try to mitigate this and try to make sure that the quality of the forecast is inclusive. So it's the same and high quality for all the regions of the world. Another thing, of course, is about being able to, again, related to what was mentioned in terms of communication, being able to communicate in a very explicit and transparent way the information about the uncertainty of the forecast or the prediction. So, for example, to use confidence levels, but also to give ranges where you give the probability distribution over these possible ranges, like, for example, for precipitation. So the transparency issue is very important in order to enable the, whoever receives this data, this weather forecasting, to be enabled to make the best decision. So overall, I tried to describe you all the pieces that we put in place at IBM to tackle these AI ethics issues for AI used in many different scenarios, because IBM has clients basically in every sector. So as you see, you have the governance on top, the AI ethics board. You have all the initiatives that identify the issues, define the principles, define guidelines, toolkits, education policies, methodologies. You have overall the external partnership. And as you see here with the pink arrows, they are meant to say that this is not a static thing. It evolves over time, is a path, is a journey that improves, hopefully improves over time, where really you have to, especially in a company as large as IBM, you have to do all these things in a way that, yes, there is a centralized governance, so decisions come from the top and are adopted by the whole company, but you need to integrate that with a lot of grassroots initiatives, because just differently that from any other discipline like security or privacy and so on, in AI ethics, the enthusiasm of the single individuals is amazing. So you have a lot of grassroots initiatives of people that even beyond their everyday job, they do things about, like a chatbot or this and that, about AI ethics that should be brought up to the level of the governance and then scaled possibly, if useful, to the level of the whole company. Here is just one example of how we also work with policymakers, and in this in particular example with the European Commission, that to put together the AI ethics guidelines for releasing what is called trustworthy AI in Europe. This was a work that took 2 years, where we participated in this AI ethics expert group that delivered these AI ethics guidelines for Europe, and then led also the European Commission, was used as a basis for the new regulation proposal around AI, which I was reflecting during the previous meeting, the previous talk. This AI regulation proposal is a mix of deontology and consequentialism. So some things are considered in a deontologic way really unacceptable, but some others are instead rated high risk. There are 4 levels of risks for AI applications, but a lot of emphasis, so risk-based meaning consequentialist, but also a lot of emphasis on impact on fundamental rights, which is more like deontology. So that regulation proposal shows an interesting combination of the two approaches. The last thing is that we don't just look at AI, but also at other technologies that combined also with AI can bring additional AI ethics concerns, like neurotechnologies, as well as quantum computing, that, as you know, IBM has a big research division around quantum computing. And so how to use this power that the quantum computing will bring in a responsible way. And here I put some useful links for people that are interested and can look, since the slides I think have been shared.
Great, thank you. We're going to switch over to questions, and our first one, and I think we only have time for one because then we're going to go have a short break and then we'll switch to the fireside chat, is how do we address the conflict of interest posed by industries and AI practitioners themselves developing their own ethical AI standards?
Well, I wouldn't call it a conflict of interest. I'm saying, of course, as I said, IBM put together this framework for handling the AI ethics issues for the AI that we produce and we deliver to our clients, not in isolation. We put it together in a really strict consultation through all our partnership with all these stakeholders. And if you look, for example, at the again, the proposal for AI regulation by the European Commission that was released a few months ago, there are many things in that regulation proposal, many obligations for providers and for users of AI that are very aligned with what IBM is already doing, and probably also other companies are already doing in their specificities of their business model. So it's not, I don't see really that companies are going astray, to define their own ethic principles. Also, again, as that regulation proposal shows, these ethical considerations that have been going on in the AI ethics communities for several years now, they are being translated into standards and also into laws, like in Europe, like what will be done in Europe. And I think that European law, when it will become a law in few years, will really change the way, especially global companies like IBM will do things. Because of course, if you have to follow a certain methodology that partially we are already put in place to comply to a certain regulation, then you're going to follow it probably everywhere. So this EU only regulation will actually be, impactful also in other regions of the world. So I don't see that a conflict of interest, but more as a co-designing these best practices.
Thank you. That was great. Okay, so here's what we're going to do for the general audience. We are going to take another short break because we're trying to be respectful so everybody gets to run to the bathroom. We'll be back in 5 minutes, and what we're going to do is we're going to have a fireside chat where we have a couple of questions we preceded, but honestly, you guys have been putting in great questions into the Slido, so some of your questions are going to reappear. We starred them and hid them in the background. They will reappear. And we're going to have, it's not just going to be Q&A, it's sort of going to be a chat. Anne and I are going to be asking the questions of Lauren and Catherine and Francesca. And we look forward to the conversation. So we'll see you back in 4 minutes. Thank you. All right, welcome back. I didn't get a chance to ask this before we did the live stream, but if we put all of our faces on, is it going to live stream all of us chatting? Is that the plan?
Yes.
Okay, good. So just the faces that are on, I think.
Yes.
Okay, so everybody who is participating, turn your faces back on, which I think is just we're missing Lauren and Catherine. There's Catherine. There's Lauren. Okay. So I think the way that those of you who are not on the live stream, we're on Zoom behind the scenes. So it's a little bit different for us because we're seeing the usual Zoom life and you're seeing a different view. We're going to try to run this like a chat so that we can ask questions of anybody and we can all just have a conversation. And in the background, please put your questions in Slido. We're going to start with just a few of them, some of which came from your earlier questions. And Anne and I are going to be doing the question asking, and Imme and DJ are moderating questions from Slido. So they're choosing what we're going to ask next. So thank you very much for everything you're doing. And Anne, I think, is going to ask the first question.
Okay. I guess I'll start with the question here from one of our first questions. So what is the biggest ethical challenge for AI for environmental sciences, given everything that you've heard and discussed today so far?
And I guess we should have come up with some ground rules. Whoever wants to answer, just start answering, and then we'll take turns. Or you could stare
Maybe
at
in
each
the
other.
absence of other comments, Francesca, I don't know if you have thoughts on this, but maybe I'll say, you know, I'm trying not to make a weather joke, but take the temperature of the Q&A from earlier in the panel. You know, it seems to me that the biggest challenge is to recognize how even in seemingly objective or numerical data or sort of measurements that seem to be very scientifically grounded, there are ethical issues, and there is the potential for, you know, biased or uneven measurements that can result. And so just be open to that. And I think this relates to a question, some of the other questions that were asked as well. You know, this doesn't mean that we should throw up our hands and say, like, we can't trust the data, we should stop our work, you know, we're hopelessly corrupted, but rather just to sort of use this as additional contextual information to inform and guide our work. And I think that's sort of a lesson that comes from feminism, which is to say, we all need to recognize that, you know, people are at the source of any scientific knowledge that we advance or that we produce or that we pursue. And this knowledge doesn't invalidate it, doesn't make it, you know, like it can be trusted, but recognizing that lets us really understand more a little bit about where it's coming from, and contribute to the complexity of the work that we do, and even potentially help us refine our work, bound it more properly, produce more validity in the kinds of work that we do. That was a little bit general, but that's sort of, I maybe we'll pick it up again, or maybe others have something to add on to that.
I completely agree, but I can also add that I think in line with what you said, that sometimes, you know, people think bias or fairness is about some protected variables, no, that are referring to people. So, for example, you don't want to discriminate on gender or on ethnicity or this. So there are a lot of these, most of the times, legally protected variables. So people think that since, you know, I'm collecting data and this data does not have these features, because this data is not about people, this data about an area, you know, the precipitation, the hail, you know, whatever. So this data does not touch upon these features of people, then I don't care about bias because they're not touching those variables, right? So instead, people have to understand that even the fact that even if it doesn't include those features, any of those protected variables, it can be non-inclusive because there can be proxies for, you know, like less density of the sensors maybe is correlated to a certain ethnicity or to a certain region of the world or to a certain protected variable. So there are links that you can do, even if in your model, in your whole technical thing, you have no protected variable at all. So that a little bit more technical, but I think is related to what was said already.
Absolutely. And I'd like to take the opportunity to ask a follow-on question that was asked by one of our participants. So what are good heuristics for developing lists of potential biases to watch out for in your data sets? Catherine, do you have a suggestion?
Catherine, we can't hear you. Very quiet. Very, very, very.
Hold on 1 second. I'm trying to.
There you go. Whatever you did, now we hear you.
Now it works? Okay. Fantastic. Yeah, I was saying I will probably start generally again in terms of identifying bias, but you know, the takeaway from feminist theory and I think other types of social justice oriented theory is, you know, to acknowledge, like as a first step, acknowledge that we have these power imbalances in the world. So acknowledge that racism is real, sexism is real, colonialism is real, ableism is real. Like all of these things are these real and legitimate structural forces that shape our environment in many different ways. Like broadly speaking, our environments, including both our, you know, actual sort of physical environments and also our informational environments. And when we start from that point, then we can say there's it's sort of like risk mitigation, right? So we can say that this is the world that we live in. We live in a world that unfortunately is not yet a world where these forces have been erased. And so we actually have to look for them. So it's really thinking about, well, I'm working with this particular type of data in this particular way, with sensors placed in these particular locales. What are ways that racism might show up in my data? What are ways that sexism might show up in my data? And I think it's sort of like coming from that perspective of it's really just the perspective of saying these are real forces and going out and actively looking for them. I mean, I think that's just like one big shift that in general, I can't speak as much about environmental science because it's really not my field, but at least in computer science has tended to try to bracket out the social and say like, oh, this is not something that we're concerned with here. Thus, it's not like a thing that we're going to go looking for. Whereas I think actually we do all of ourselves a much greater benefit if we say, oh no, this is real, this is within the sphere of the study, and we have to go out and look for these things, and then actively think about, like, first of all, how might these forces enter our data systems, and then what are ways that we can mitigate that, knowing that they will. Like, none of us is going to be purely anti-racist, anti-sexist, whatever, because it's just not the world we live in. It's more about a question of like, how will we navigate the racism and sexism that will enter into these systems? And can we do that acknowledging the very realness of these forces?
Excellent.
And Francesca, I don't want to add to that. I'm gonna ask a question. So I think we're moving to some of the Slido questions. So this is one from earlier that I really, really liked, and I wanted to make sure we got to. It's from Douglas Rao. How would citizen science and other similar community science efforts fit into the landscape in addressing the missing data issues? So if we're trying to do citizen science and collect weather data, for example, from lots of places where we don't have the expensive instruments, how do we avoid, when we're doing such projects, reinforcing the missing data issues and the other biases, right? Because we might get the citizen science project observations from only certain segments. So how do we design projects like that to avoid that issue?
I'd like to tell a story about that, just to validate that as an issue, because there's a counter data project that came out in the US context, and this relates to police involved killings. And so there's a database that's been compiled by The Guardian, because there is no comprehensive federal archive of police killings. So The Guardian and the Washington Post actually both have databases that they're assembling. So this is kind of that, again, that idea of counter data, where it's the journalistic organization that's producing the data. But then I was in conversation with a group that's led by Indigenous folks that's monitoring gender-based killing of Indigenous women. And the woman leading that group expressed a lot of frustration about that database, because she said, you know, this database would be so useful for us except that they don't identify, they have a race variable, but they never identify Native people. All Native people are lumped in as other, and thus it's like rendered it completely unusable for us. And so I found that really interesting because it's sort of like, it's this counter data effort that was meant to address this issue of missing data on the one hand, and yet at the same time, they're doing their own kind of erasure because they're kind of not classifying things in a way that could actually correspond to like helping some of the folks that want to use their data. And so I just think it's like a very real problem of like, how do we not reinscribe those same power hierarchies, even as we're trying to pursue these more participatory counter data, alternative ways of collecting data that we don't have access to and should have access to for important reasons. And I think just one strategy of mitigating that is, again, sort of being in dialogue with people. This is where dialogue comes in to be really important. So the step that the director of this organization took was she actually emailed the journalist, but she never heard back. And so nothing was done. So the database has stayed the same. But I think this is the kind of thing where you think about, well, like, how can we be constantly open and constantly sort of modifying our taxonomy, constantly in dialogue about thinking about like whether we have the right categories, how we're validating our data, who's using the data, and so on and so forth. So thinking about it as like a open and relational system rather than a one and done. We've made the taxonomy and the classification scheme. We're just moving forward and getting these citizens to get our data, basically.
Yeah, that's why these multi-stakeholder, initiatives are so important, because they raise the awareness in general, and then hopefully goes into the each specific project, that these decisions, like even the decision of which classes to consider, where to label, which labels, list of labels to consider, has to be coming out of this multi-stakeholder approach, where one of the stakeholders definitely is the communities that are impacted by these decisions or engaged in the decisions. So that's really very important. But together with that, there is also the issue of, as you say, communication, but also transparency, So suppose you put together, even in a multi-stakeholder way, a certain list of labels, well, be transparent about it so that maybe somebody else can notice out of these multi-stakeholders that you consulted with, can notice and then can participate and make you notice that some label is missing. So there's two cores or some community has been forgotten. So very important.
Great. And just one quick follow-up before we move on to the next question. As you both have highlighted, that it's important to involve multiple stakeholders and to pay attention to this and to try to open and make these processes more transparent and to capture biases that you might otherwise not catch. How do you decide, how do you discover the stakeholders you need to include? They don't always come to you, do they?
Well, I mean, if you are, for example, defining the labels, no, in this particular example, the labels were the various ethnicities, okay? Of course, you need to make a decision about how coarse you are or how fine-grained you are. And so, but you have to decide that possibly together with some of these communities in a kind of possibly inclusive and diverse way, so that, even if you forget something, then somebody else reminds you, oh, but there is this community that you didn't remember. So I think that, and again, we found at IBM that these design thinking sessions help developers and designers of AI system to get into this frame of mind of before started coding, you need to think and reflect about the consequences. Who is going to be impacted? Who is going to be subject to the decisions of this AI system? And so that puts you in this frame of mind where you try to be as inclusive and diverse as possible. But yes, you need to change the culture, because usually developers, before all these issues came up, they were more like just technical people, used to talk with other technical people, period. So they were not used to do this multi-stakeholder thinking and impact analysis.
Great. So I'd like to, Catherine, please go ahead.
Well, it was me. Catherine also unmuted. I was going to go into a related question. Catherine, go, and then we'll all figure it out.
Yeah, and I've
Make it quick, just to build on that, I was gonna say, yeah, I actually think this is a really underfunded and under-recognized skill that we don't tend to be, especially in large grant applications or industry-led projects. It tends to be about like, what is the output and et cetera, and there's like less focus on the process and like how you are going to get there, particularly like valuing participatory process. Because the thing is, with participatory methods, these relationships, it does take a really long time to find the communities to work with, to build a partnership, to build trust. These things don't move at the same speed as like, okay, let's just like, yeah, like go get to coding or whatever, as Francesca was saying, you know? And so I think it's an area just to be highlighting that if we want to encourage more work in that way, it's an area that we actively have to help researchers and developers and technical folks build their skills in those areas, because we don't really teach in that way right now. It's not the norm, definitely not for data science and computer science at least. And then we need to think about like, how do we value and compensate that work as well? Because like, as those of us who work in a participatory way know, that it takes time and you need to get together with people and you need to know them and they need to know you. And those, you know, we at the very least need food budgets, you know, so we can like feed people and build some goodwill together. And so I think it's just it's an area for us to be kind of, those of us who have access to structuring opportunities like grants or awards or whatever it might be, to really think about, if we want to work in this community engaged way, how do we really recognize and research and recognize and like reward that as real true work and labor that that has real skill involved with being able to do it ethically and well.
I just thought, I know we have so much to discuss, but I just wanted to put some specific examples of folks who have attempted to codify or proceduralize these types of relationship building and sort of ethical approaches to community involvement. I thought I should mention the Clear Lab, which is run by Max Lieberon out of, it's based out of Newfoundland, I believe. I'm going to paste the link in the Zoom chat. I don't know if this can get translated over to Slido, but they have both a very sort of consensus-based, anti-colonial, feminist approach to, I believe it's marine biology and environmental science more broadly. And they publish a sort of a lab guide, which is a really active and evolving document that tries to just record how they attempt to do things like community engagement, which I believe they actually sort of refuse to call or understand as community engagement, because that's very one way. But that may be interesting to listeners. And then the other really interesting resource is the Indigenous AI Working Group. And what they have done is, with this emphasis on reciprocity and knowledge exchange, which comes from many Indigenous cultures, this idea that sort of knowledge is only gained through a long-standing and sort of trusting relationship that unfolds as you get to know more about the other party. And also, I would say, sort of the knowledge of the knowledge extraction that comes from so these external studies of native lands. They've also developed a sort of series of principles and statements about how they believe that research partnerships should be structured. And I would direct people there as well, just for some, again, these are open issues, right? Like, clearly you can take a look around you at the work being done. We haven't solved these things, but I do think there are people doing really great work trying to articulate and codify and describe how we might move forward in a better way.
So I put in the chat a link to another initiative that we have at IBM, which is called Science for Social Good, where we have summer interns that come to IBM. They're mentored by IBM researchers, and they work on a specific problem with specific data given by an external entity, like a foundation or that they have something usually related to a sustainable development goals of the UN. And so the idea here is to educate the next generation of developers, but also possibly managers, also executives or whatever, to value the that the multidisciplinary work, because these students come and they need to work with this external foundation. They need to get the data from them and they understand what this data means and what the possible things, concerns about the data is. And so to educate them to multidisciplinary work and multi-stakeholder work, which is not something that students are educated at. And so that is really very important, because when these people will go into the job market, they will bring that attitude, hopefully, and this will be reflected also in how they do their job, but also how they evaluate the job of others. Because as you say, doing this kind of work takes more time than just getting there and coding and produce and getting the product ready in 6 months. So the manager of these people has to evaluate them positively if they spend more time, because they need to take care of these other aspects that are essential in delivering a product or a service that has all the properties that we want.
That's a really good point. Making sure that it's part of what's valued in your work. And I think in academia, it's also not, it's only slowly becoming valued in computer science, at least. And that actually, okay, so that brings me to the next question that I was going to go to a few minutes ago. I'm going to reword it from what we wrote in our Google Doc originally. I feel like there's a community that knows that there's biases in the weather data and the environmental science data, and that we've been talking about, and that some of the, like some of what we're talking about is great for that community that already knows it. There's another side of the community that doesn't believe it exists, right? The weather is objective and therefore it affects everyone and therefore there's no bias in it. So how do we continue to spread the word that if we're going to apply AI to weather, that we need to be very aware of these biases? And how do we get it beyond the small community that is already aware? I see lots of head nodding. Who wants to tackle that? I'm sure the answer to that is it's hard, but I would love to hear it.
Yeah.
Again, there are all these forces that I mentioned, no? That push a company to say, okay, I need to look at this and maybe I need to do something about it. Like, I don't know, you may know that there are these external, third parties that evaluate the accuracy or the quality of weather predictions. The weather company is ranked first. So a company that wants to be ranked first itself should say, okay, but what are they doing that I'm not doing? How are they keeping the accuracy balance and also high, also when you don't have enough data? So I think that there are all these forces, market, evaluation. So when they go and they try to sell their product, and people say, but how come you're not the first one? How come you're the 10 in this ranking? So I think that there are forces all over that more and more will push companies to be more, thinking about this, to be more educated about these issues, and then to do something about it.
How about the academic side too? Like, how do we make it valued for our students and faculty?
And I think also, one of these very basic feminist tenets, I probably already said this before, it's rarely that we encounter an either or situation. This goes back to what Catherine was saying about rejecting the idea of a false binary. Like, if you can, hearing Francesca talk about that, I was reminded about the conversations around university ranking systems and how there have been certain arguments made, I think particularly by Kathy O'Neill in Weapons of Mass Destruction, about how if we wanted to value the right things in college campuses, there, we can push some levers, for instance, in the US News and World Report's ranking systems about what makes a college valuable. And if we choose to value certain things like the ratio of tenure line versus adjunct instructors, or whether or not they offer full benefits to all employees of the university, right? Like those are metrics that matter to certain groups, which may not matter to other groups, right? But doing that kind of thing doesn't negate the need or the desire to also go in from the conceptual side and say, let's just keep on talking about how, we live in a complex world which involves complex systems, and none of these are isolated from any other one. I was going to bring in, there's a really helpful concept from Dr. Ruha Benjamin, who's a sociologist and professor of African American studies at Princeton. And she has this really nice phrase called imagined objectivity, which is intended to describe, our idealized version of what objectivity would be if it were possible in some idealized world. And yet we know that we don't live in ideal conditions, right? We live in a messy, complicated, fraught, global system in which our objectivity is compromised. And again, to get back to something that I was saying before, this doesn't just mean we should throw up our hands and say, let's stop collecting data. We should use this to inform our work, to guide our work, and to contextualize it so that we can draw better and more valid conclusions from it.
Maybe I'll just piggyback on that and say, I think there's a couple powerful ways that have been alluded to so far to getting the word out. Teaching, I think, too. Either in an academic context or in a professional context, like sort of thinking about like workshops and capacity building. I have great hope from the students that I've been working with, at least, who already are thinking in a very justice-oriented way, in an interdisciplinary way, who are sort of challenging some of the dogmas that come from different disciplines and say, no, actually this concept from this discipline does relate to this discipline over here. And so, I think that's one of the strategies that Lauren and I were also pursuing in data feminism is like, we're trying to write a really accessible book as a way of, getting picked up and reaching students who are in these really formative years, learning about all of these concepts so they can start to build them in and start incorporating them in kind of creative ways that we can't even imagine right now. So I think that's one. And then I think the other thing for getting the word out, in particular, like for reaching people who may be more senior, who are who are kind of more fixed in their view, I think one powerful mechanism that we talk a little bit about in the book, in the challenging power chapter, is this idea of audits. So just taking a very data-driven perspective to the matter and just systematically demonstrating inequitable outcomes, inequitable harms, and so on and so forth, either through a kind of a generalized approach, so like a systematic audit of some kind of system or of a data set or something like that. We see both of these things in Joy Bolam-Weeney's work, if you haven't looked at her work. So there's a way you can like sort of audit large data sets and look for biases. But then I think there's also an approach that Joy Bolam-Weeney has pioneered, which she's been calling the evocative audit. So it's really showing what happens when an individual person kind of comes up against these systems and the ways in which the systems either erase them or misrepresent them or cause harm to their community in some way. And so I think that's another way to kind of confront people with like, actually there is, these are not objective. These are like sort of demonstrating by showing here's how these systems are failing for these specific groups of people. So I think those are also strategies to, of evidence building, as it were,
Excellent discussion. And on the topic of evidence building, we can come to another question here from Slido. The unwillingness of organizations to release data for research has crippled, oops, my screen just disappeared, has crippled some research communities. What standards are there to deal with this, since data are power and machine learning is highly dependent on data?
Directed at me, so I'll start. Yes, I think this is a really big issue, and I think in particular, I don't know if folks in this community were following what happened in 2016 with the election of Trump. Then a lot of the EPA's data started getting taken down, and there was even like a kind of data, they framed it as a data rescue effort, the EDGI group, who was actually going in and like downloading all the data sets before they were taken offline. So I think there are these kind of there's political context in which like we cannot access government data because there's like interest in keeping it secret. And then of course there's corporate context in which corporations' data are so highly valued by corporations. And also corporations don't want those algorithmic audits that I was just talking about, or they don't want them from outsiders at least. And so there's been, I mean, even a couple of Supreme Court cases around ways that researchers can acquire data from large companies, even just as a public and transparency function. So, I mean, again, this is another reason why sort of like data are political, right? And so I think in these cases, this is why we need better data regulation, better data governance. We need to fortify our open data frameworks and efforts. And really, again, it's like comes back to money, like invest in those. So I think a lot of even open data efforts falter because, you know, one thing to like kind of throw a bunch of data files or zip files up on a server, and then it's another thing to actually really carefully annotate it, steward the data, care for it, help people use it in the appropriate ways, understand what its limitations are, and so on. And we've tended with open data efforts to invest more in just the pushing it out there, if we do that at all, and then not really stewarding the metadata side of it. So I mean, there's like a lot to do in that area, and I think what I would say is like the questioner is right, but again, it's like a reason to kind of like get involved and think about how do we build coalitions to fortify these efforts to basically just advocate for more resources. Yeah, I don't know if others want to add something there too.
Francesca, would you like to add the voice of industry to this?
Well, I mean, as I said, IBM is not a consumer-facing, mostly not consumer-facing company. No, so we get the data for building our solution for a client from the client themselves in a bilateral agreement. You know, so the hospital gives us the data, the bank gives us the data, and then we train our pre-trained model on their data, and then we test or whatever, and we deliver. So we don't generate data ourselves like other consumer-facing companies using AI, like search engines or social media platforms and so on. So they have their own data that they collect. So that's a bit of a different situation. But I remember that we had an initiative that was not very successful, actually, about collecting data for research purposes. It was done within IBM Research to collect data for helping research on face recognition to be as fair, as inclusive as possible. So we collected, I don't remember how many, maybe 1 million faces, pictures, you know, and it was called like diverse faces. We collected from the web, because again, we don't have our own data. We collected from the web when where there was a license that allowed us to collect those those pictures, and then we put it together, and then we released it as a data set that would help making these kind of technologies based on those pictures more diverse, because more inclusive and less biased. So it was a contribution to this issue of AI bias in that particular technology, but they received a very negative, very negative feedback from individuals that owned those pictures, that put those pictures on the web, even though those pictures were released with a license that allowed us to pick it up and to use it for researchers. So then that initiative was shut down. They said, okay, we're not going to. So I think that people also, so again, there is a difference between companies that collect their own data, and companies that don't have data and maybe try to get data, and that's one example of when we try to get data in a way to support the AI bias issue resolution. But the other data that we get is from our clients, and it belongs to our clients. So we are not sharing it because it's not ours.
All right, I think we're gonna have time for maybe 2 more, maybe 1 more. We shall see. The next one we're gonna talk about is, I think it's moved to the top. Is there a further ethics challenge? Machine learning approaches come equipped with a loss function and an optimization scheme to minimize, and introducing statistical assumptions for convergence guarantees. Poorly chosen approaches may cause machine learning to not be aligned with the users. So it could be ill-specified goals, etc. So how do we handle that? I think Lauren said she was going to comment first on that one.
Oh, yeah, sure. So, I will say that my background, I mostly deal with text. That's the kind of data that I work with, and I primarily use methods of text analysis, so statistical approaches to large, big textual data. And so, but I would say, first of all, the most important thing, and I think this is, in many ways obvious, but we need to really recognize these challenges in these applications as true interdisciplinary collaborations, right? And I encounter this all the time where I am taking research from one field, usually from fairly technical machine learning, and trying to apply it to cultural data. And there's always a translation process that needs to happen. And the best applications are those that come about through collaboration. When I'm talking with domain experts, with technical domain experts who not can just tell me, but we can have conversations over the research process about, what are the best things that this approach can find or do, and what are the things that we can pull out when we take this approach from one domain and apply it to another. And I think most of the misapplications happen, and these poor alignments happen when someone is enticed by the shiny new toy or whatever the hot new thing is, and they think, ooh, like, let me just sort of smush my data into this model and see what happens, and they try to make sense of it afterwards. And so I think really valuing, and actually this interestingly goes back to this question about community engagement, putting time in those conversations as you're framing the question, as you're bringing together approaches, I think ultimately safeguards against some of those misalignments. But the other thing that I'll say just more generally about sort of what statistical approaches are generally designed to do, which is like to converge, to fit, to sort of best capture the median. And again, this is something that I deal with a lot in text, and also just my own research interests, which have a lot to do with both applying machine learning techniques to again, like this big cultural data, but also I'm ultimately most interested in the outliers. I keep a very careful eye to, if I'm running a classifier, if I've designed a classifier, like what are the examples that really break it, that have really poor accuracy or precision or recall, right? Like what can I learn from those? Or similarly, if I'm looking at, if I like, do some, multidimensional thing, and then I look at, do some PCA or whatever, like, I'm like, okay, well, what are the things that are on the really far edge of whatever, graph or visualization or whatever it is that I'm created? What can those tell us both about what the model is doing well, how well it's performing, and then what are the components or the types of data or the interests that this model really fails on? And I think if we devote equal attention to those outliers, we can really learn, again, this is like I'm sounding like a broken record, but I think the end goal is not to say like we should never use this, but to say, okay, here's where it works really well. And here's this whole area where we need a better technique, or we need to supplement the technique that we're using because it only works within these certain bounds, or for this type of data, or within this range.
Excellent advice for everyone. Yes, and you want to say something?
I was just going to say we're going to have to wrap up. Yeah, you wrap up. I was just going to remind everybody of tomorrow. You do it.
Go for it. You're right. Hopefully we'll have time for you to remind everybody of tomorrow. We'd like to ask each of you if you have any final additional advice for AI researchers in the environmental sciences based on your own experiences.
And let Francesca go first, because she has to drop right at the hour.
Yeah, like I think that we said it already, but really in terms of these, ethical considerations or bias in particular, really to understand that, this kind of data may impact on people in different ways, and on those so-called protected variables, even if those variables are not there. So so you need to enter into this frame of mind that you are impacting people in maybe different ways, in a non-inclusive way, even if you are not taking really these variables about people in the system. So to think about that, and to think about how the two things are related to each other.
Thank you, Francesca. Lauren, or Catherine, you're up.
Yeah, I think I would say just, for people who are starting out with this, where they may feel that a lot of this is new, or they don't yet feel equipped to be doing this kind of work and whatever kind of training they've received, I would just say to stay with the work, and you don't have to do it alone. And I think that's one of the biggest things to be thinking about here, is the ways in which Like Lauren was just describing her collaborations with computer scientists who work on NLP, for example. Like, we don't have to answer these things only as our individual selves coming from our particular thing. This is one of the reasons like we co-wrote Data Feminism, because we're like stronger together, right? And so thinking about ways in which you may not know how to mobilize a feminist or anti-racist perspective, but you probably have colleagues who do, or you probably know community groups who do. And so thinking how you can operate in collaboration with them and dialogue with them. And, you know, it's a slow process, and none of us have all the answers because these are really fraught issues. And the most important thing is that we just keep working on them. We use this particular cultural moment as a reason to push our own selves and our own work forward in that regard.
Yeah, I'll just continue to build on what Catherine said because I endorse it 100%. You know, just to say that we all have perspectives that can contribute to this common goal. And if we approach any sort of shared goal from a perspective that we all have things to bring, right? That people from more technical backgrounds can be in dialogue with and contribute equally to those who come from more social scientific backgrounds, who come from more humanistic backgrounds, who come from public, private, you know, all of us bring our own perspectives to this work, and they are complementary and ultimately enhance each other. And so really just to embrace that. And, you know, it's such an interesting conversation in which all of us learn. You know, I think all of us, even through this hour today, have learned so much from these questions and from being in this audience. And I would just encourage those of you who enjoyed listening to, as Catherine said, you know, to stay with it. And we look forward to hearing more about what develops after this.
Thank you. That is a fabulous ending. Thank you all for the day. It was a great day for summer school. And tomorrow we're focusing on case studies, and we'll see you back at 10 a.m. Tomorrow morning, Central Time. Thank you.
Bye. Thank you.